Hello and welcome to the Delphi Training Series, brought to you by 3dbuzz.com. I'm Buzz.
And I'm Logan.
And here we are at episode 3 in this incredible training series where we take those wanting to become programmers and we make them programmers. Well, that's the goal anyways. We teach you guys how to use the Object Pascal language and how to use the Turbo Delphi IDE, which is freely available on the internet, to write your applications. Now, with each episode, I have promised that we are going to show you guys how to write some sort of little program. And we've done just that so far. With episode 1, we showed you how to create your own floating window. All right, that's not very exciting. Then we showed you how to take it a step further and put a button on the window and have it so that a user can click the button and a message box would pop up. Ooh, now perhaps you can, impress your relatives, your wife, your friends, whatever. From there, in episode 2, we went a step further and we showed you how you can put text fields on the screen and get input from a user, basically allow them to type something in, and then hit a button and manipulate whatever it was that they typed in. We showed you how we can convert their data into all lowercase characters, all uppercase characters, and even how to reverse the characters. Again, these applications aren't very useful, but the idea is to slowly get you up to speed by writing these applications to becoming a programmer. Now, here we are at episode 3, and I am about to up the bar significantly. We are going to write a really, really amazing application for a beginner, as far as I'm concerned. I mean, this thing's going to be crazy, which means that you guys are now in for a very long VTM, so you need to go grab some coffee right now and then buckle in, and I mean buckle in tight, because if you're new to programming, you're going to find some of the things that we do in this particular VTM confusing. But relax, have faith in us and confidence, follow along, and I promise by the end of this week, where we've released episodes number 4 and episodes number 5, a lot of this stuff is going to become a lot more clear. In fact, you'll find a lot of the new things we introduced in this particular video pretty clear by the time we get to the end. Now, what is this crazy application I'm talking about? I'll tell you in just a minute. First, we have something else I'd like to bring up, and that is we've been hosting these videos over on YouTube. And because of the format of YouTube, you guys know that the videos are very low in resolution, making it difficult for you to see some of the text that we type on the screen. Heck, what am I saying? All of the text that we type on the screen. Fair enough. And I, of course, do listen to your guys' concerns. So what we are doing is we are making the high-res version of these videos available, again, for free, but you need to get them from the YouTube site. If you go over to YouTube, you will find that after an episode goes up, it'll take about 2 days, because I want to, of course, get the views on YouTube with the video that we just released. But after about 1 to 2 days, you will find a link appear on the right-hand side of the video, and that link will take you to 3D Buzz to where you can download the high-res version, and there you go. You have it on your computer. You can see everything we type in relatively perfect clarity. Notice how I said relatively. It's still a little blurry, but it's still a lot better than what you've got right now. So, there. Out of the way. Done. That's a lot of talking. Let's get back to this really cool application that I'm talking about. What is the application we're going to write? Yeah, here it comes. It's a game. Logan, go ahead and launch the game. Ta-da! Now, we'll start playing it in just a second, but we're going to show you guys how to write the game Flea. And we think it is one heck of a beginner project. Wouldn't you say, Logan?
It's one heck of a project for a beginner. It's a big jump.
It is. And for someone who's just getting into programming, they want to do something cool. They want to show their friends and family, look what I wrote. This is awesome. They don't want to show them floating windows with a button that says, hello world. That's boring. This will not be boring. Before Logan hits the start button and you guys see what it's going to do, let me tell you the different objectives that we are going to conquer in this video. We're going to take a look at how to create a splash screen. And you guys are looking at a splash screen right now. Flea, click start to begin. We're going to show you how to create a simple HUD. And you can see right now we have a very simple HUD right here. It's going to do things like show you what level you're on, what your current score is, what your high score is, and of course it's going to sport a start button that will, of course, start the game. We're going to have a controllable player. You're going to be able to control the player with your mouse as you move your mouse around the screen. We're going to show you how to create some very simple enemy AI, artificial intelligence. We're going to show you how we can make an enemy hunt down the player. So that's going to make things interesting. We're going to show you how to do some simple collision detection. Basically, we're going to check to see if the enemy has managed to catch the player. We're also going to take a look at changing difficulty, changing graphics, and things like that. Obviously, the game wouldn't be any fun if it didn't get harder and harder and harder. Notice the level down here. I know right now this is very hard to see. That's because the game hasn't began. But in a second, when Logan starts the game, this will all light up. And as the levels increase, the game becomes more and more difficult to play, which is really cool. And of course, that contributes to a higher and higher score. So that's our goal. And now we're going to do all of this in this training video. And like I said a minute ago, this is going to be a long training video because of what we're trying to accomplish here. But we're doing this for you guys because we want to show you something cool so that we can encourage you guys to develop your own simple games like this and then share them over on 3dbuzz.com. As a matter of fact, if I see some really cool ones pop up, I'm going to promote those in our own training videos here so that other people will be interested in grabbing your games too. Now, Logan, let us show them how this game works.
Well, let's begin.
We'll click the start button. Ta-da! There's our little character. You'll notice that we borrowed the icon from Doom of your character in that game. Again, this is for educational purposes only. Now, what's happening here? As Logan is running around the level, go ahead and let him kill you. Bink! All right, so Logan was running around the level by simply dragging his mouse around and the character stayed up underneath the mouse. Simple enough. The creature, which is a spider-looking character, hunts you down and tries to catch you. As the levels continue to increase, the creature gets faster and faster and faster until you finally reach a point that he is indeed going to catch you. And at that point, you have your final score. Now, in this particular game, since we just launched it, you'll notice that Logan has just got the high score. So the screen is showing us, congratulations, you set a new high score. Game over. Click start to try again. Now, some things to pay attention to. In a second, when Logan clicks start again, you'll notice that the high score remains at 4,072. You'll also notice that the score will go back to 0 and you will go back to level 1. If Logan starts again and gets killed relatively quickly without beating that high score, you'll notice that he is not, greeted by tons of beautiful women and champagne because he doesn't get a new high score. It's just simply game over. So let's go ahead and start the game again and get killed relatively soon. Aw, game's over. No really cool prizes or anything like that because the score this time was only 160. Now, go ahead and try again to beat your 4,072 to show them a new score getting created. In the meantime, if I can bring your attention to the lower right-hand corner, viewers, you'll notice that the start button has been disabled so you cannot start the game again after it has already started. Notice our backgrounds are changing. We've only got 3 that we rotate through, but after we are done with this training video, you guys will find out how to, make as many backgrounds as you want. Ta-da! So there we are. Logan has scored 6,560, and that is indeed the new high score. Now, for those of you out there that do have some programming knowledge, yes, we know this is a very, very simple application. But come on, guys. The idea is to show the beginner how to make something far more interesting than a simple hello world or hey, check out the text that he typed in. It's now all lowercase and uppercase type applications. And I think this qualifies, don't you, Logan?
I mean, not only that, it looks like it goes a step beyond a Windows application graphically speaking.
That's true. Because
you'll look at that, and instead of the first thing coming to mind, hey, look, fields and buttons. You'll
exactly.
Go, hey, look, a HUD.
Exactly. So, and a HUD that really works. I mean, numbers that are changing, etc. So this is what we're doing. Yes, it's going to be involved, but I think you guys are really going to like it. And I refuse to break this video up. I've already had several people suggest that I do that because it's going to be so long. But I really want to keep the whole thought process together because I know you guys are not going to want to wait for like part 2 and part 3. By the end of this video, you're going to have a fully functional game and enough knowledge that you can go in there and enhance this, change the graphics, etc. without any problem. Now, let me go ahead and bring your attention to some of the new stuff we're going to be talking about that we are asking you to just have faith and trust us as we go through the coding process. We're going to be talking about if statements. Obviously, with any program that you write, you're going to come to a point where the program needs to make a decision. If this happens, do that. If that happens, do this, etc. So we're going to have to use if statements in this application. In this episode of the Delphi Training Series, we are not here to teach you the if statement. That's actually going to come up here in the next couple of episodes where we're going to take an in-depth look at it. So by the time you get done with this video, you're going to be pretty comfortable using a simple if statement because you're going to see it over and over. If you have trouble with it, just type what we type and have faith. We will teach you how to use the if statement with careful precision in a couple of episodes. Now, we're going to introduce a variable. A very simple variable because we have to have it because of a particular function we're going to use. Again, have faith because we're not teaching variables. For those of you that are programmers out there, this is very important. You're going to see we're going to do several things that you would normally do with variables, and instead we're going to show a different way of storing the information in this video so that when we do teach variables, which is coming up in probably the very next episode, it's going to make a lot of sense why variables are important. And I've come to this teaching method because of years of teaching people how to program. And you get into teaching variables and you get your absolute beginner completely confused. And we've come up with a method here that I think is going to really prevent a lot of confusion. All right, and we've got some simple math. We're going to do some division, we're going to do some addition, and we're even going to do a modulus function. And that's another area that's going to be at the very end of this VTM that we ask you to simply have faith in what we're doing. Okay? Now, with that, we've got something else that I want to bring to your attention. In this video, we are going to need to use a whiteboard. So I've got Photoshop set up, and my drawing skills are not the greatest in the world. If you happen to take a class with me, a real class, and I'm your instructor, you will find on a whiteboard, I write about the same way. I write bad. So you're just going to have to get used to it and deal with it. But a whiteboard to me is very important because it does allow for me to demonstrate concepts to you guys that would be very difficult to just explain verbally with no sort of, here's a box and this box could go this way and it could go this way. It's a lot easier for me to draw stuff out. So a whiteboard will be introduced in this particular video. Okay, let's go ahead and bring Turbo Delphi back up. Now let's see. With that out of the way, Logan, I say we get started.
Yes, I agree.
Logan, you have talked way too long, and I know I do that. So the first thing we're going to do is go ahead and start a brand new VCL Forms application. So VCL Forms application, here we go. This, again, the visual component library where Delphi gives you a rich world full of visual components that you can drop on a window and interact with. Now, if you guys do not remember everything we taught you in Episode 1 and Episode 2, it's very important that you go back and look at those again because we are going to make very heavy use of everything we showed you in both of those episodes where we started talking about objects. And objects have properties, and these properties can be set and manipulated. And also objects have events. Again, all of this is going to be very important. So this is going to be an excellent demonstration of how object programming, if you will, can be so helpful. All right, so where do we want to start first with our incredible game?
Well, right off the bat, I want to go ahead and get this saved and get the project set up just so we're set, we're ready to go.
Okay, sounds good.
So saving this out, we'll make a folder for it. And so the game's name is Flea, so that'll work fine for all of our naming here. The main unit can simply be called main.
Fair enough.
And the project can be called Flea.
Flea, all right. Good enough. Now let's go ahead and set some properties with our form itself. I don't want you to take away the ability to resize it on the fly because I think we're going to find that useful here coming up real soon.
Right. We have to build a few of the interactive elements, and we need some room to work with to show those off.
Right. But there are a couple of things that I think we can go ahead and set now, such as the caption of the form. So let's select that object and set its property to Flea. Now let's go ahead and set a size. And we've got a predetermined size that we're going to use because our graphics were created to a specified size. So 434 for the width and 320 for the height. So this will be the size of our application, our game, and it's going to be locked to this size in the end. Right now we're not locking it to this size again because I'm going to want Logan to be able to resize this while it's running to demonstrate a few things to you as we progress through this video. All right, so now that we have that set up, where should we start first? I know. How about introduce them to timers? That's a new object. Yeah. We can show them what a timer is and how to manipulate it and how to work with its event and go from there. I mean, you guys have seen up to this point, the whole idea is being able to come over here and grab things like a button and drag a button out on the screen, and then you have properties you can set and events that you can control, right? Well, we're going to introduce you to a brand new, let's go ahead and delete that off real quick. There we go. A brand new object that you have not seen yet, and it is a timer. So show them where they can get that.
All right. The timer is located within the system group on the tool palette. And I'm going to scroll just for the first time. If you want to get to this faster, you can jump to any of these sections with the little drop down.
Okay.
But I'm just scrolling just this one time. There we've got timer. So we'll create one of those on the form, and there we go. We've got a timer.
Now this is a non-visual component, meaning that at runtime you will not see the timer. As a matter of fact, Logan, let's go ahead and run the application. So what hotkey did you just hit?
F9.
F9, okay. I just want people to get into a habit of knowing what hotkeys you're doing. All right, so here we are, application's running, but notice you don't see a little clock on there. We now have a timer, and we are able to work with it as you're about to see. Go ahead and close the application.
All right, again, its job is not to be seen. Its job is to cause other things to happen.
So with the timer selected, let's go over to the Object Inspector and click on the Properties tab. Now, the most important thing in here is going to be, as a matter of fact, let me grab the mouse here and I'll show you guys. The most important thing is going to be the interval. This is in milliseconds. Now, 1,000 milliseconds is 1 second. So what this means is every 1 second, we're going to have an event that gets fired. This event is found up under Events. Notice that we only have one event, and it's called On Timer. So if we put some code in here, what will happen is every 1 second, that code will get executed. That's the whole idea of the timer. Now, with just about every object we drop inside of Delphi, when we are creating a VCL Forms application, we have an enabled property. If this is an object that a user can interact with or that can be turned on or off, you're going to have enable so that you can simply disable. An example of how this works. Watch this. Let's go ahead and scroll back over here in our tool palette all the way up to a button. That'll work. So we'll draw a button out, and when we run our application, you'll notice that the button is enabled. Right now, you can interact with it. If I was to select this button and then come over here in the Object Inspector up under Properties and take Enabled and change that to False, now watch this. When we run our program, it is no longer enabled. The user of your application cannot push this button. Well, the same thing's going to apply for a lot of the different components that you can put on your forms in Delphi. This timer even has the ability to be disabled. And the cool thing is, when it is disabled, what happens? Well, it no longer fires the on-timer event every time the interval hits. So we have a way to start it and stop it. We simply use the property enable. Okay? Now, we've got this in place. What do we want to do, Logan, so that we can demonstrate it working? Well, since we're going to make a game and we're going to have a character move around, let's start out by just making a simple shape and have that shape move, and that move be controlled by the timer.
Okay. Have the shape represent the object that we want to use as a
player or enemy or something like that. We'll do enemy. Yeah, sounds good.
All right, so I'm going to jump down to additional where we have shape, and I'll create a shape.
Okay.
And just to keep this up to speed with what our goals are in the end, I'm going to resize this down a little bit.
Okay.
And now we've got a
32 by 32 because our graphics were created in Photoshop at 32.
Again, just keeping in mind what our goal is, so we're sizing everything, getting it ready.
For sure. I just want everybody to understand that when the graphics were created, they were created by Zach. We asked him, could you please make our character and our enemy at 32 by 32 pixels? And so that's why Logan's setting that here. And we're also going to start setting names. So let's go ahead and set the name for this box to, we'll do enemy. All right, so this is going to be our enemy, so you must change his color.
So, I mean, you've got to have red represent the enemy. I mean, red, evil, and goes hand in hand.
Agreed. Okay, so now we have an enemy. What we want to do is make this guy move. I want to show you how easy it is to make an object move on a window. So to do this, let's go ahead for just a second and jump over here to our whiteboard and give you guys a quick idea of what we plan to do. So here is our very simple enemy, right? Now, an object is positioned on a window using two properties. It uses a left property and it uses a top property. So let's say that here is a part of my application form, the window itself, right? By using just these two properties, think about it, I can specify where an object is anywhere on a window, because left is going to be how far over we are. So you can almost kind of think of left like X in the 2D world, right? Top is going to control how far up and down the application is. So you can almost think of top kind of like Y. Do you agree with this, Logan?
Yeah, I mean, depending on how you look at it, it could be reversed Y, but then that gets into coordinates.
Yeah, so we're not going to do all that crazy stuff.
Looking at left and right, up and down, those are represented by X and Y commonly in a 2D plane.
Exactly. Now, if I was to come back over here into Turbo Delphi and take a look at this, with the shape selected, I can, let's see, where are we at? Come on down here up under the visual section, and we have a top. It's currently at 40, and we have a left. It's at 56. So I'll select those so you guys can see what I'm talking about. Now, by changing this, so right now we've got left at 56. If I was to set that to 0 and hit enter, look at that. We jump all the way over. Now, let's take that little piece of knowledge, come back over here to our whiteboard, and what happens if I was to take left and increment it? So let's just pretend that this guy's name is E, so I don't have to type a whole lot or write a whole lot. If we said something like E dot left, because remember, we're talking to our object, and then what on the object are we talking to? We're talking to the property. Now, if I said that equals 50, all this, and we'll put a little terminator at the end, all that's going to do is set my enemy left at 50. So it's going to move him over in this particular direction. So let's say that going over in that direction, this is 0. Let's say that this is 25. And then let's say that right here is 50. What's going to happen is our enemy would then be placed right here. Notice how up and down he hasn't changed. And the reason he hasn't changed is because we didn't talk to the top property. We only talked to the left property. So this just puts him in one place. He's not moving. We just moved him to that place, right? Like if I said, Logan, you're going to live at, and I give you an address, you're just going to go to that address and stay there. You're not going anywhere else. But if I said, Logan, you're going to live starting at this address, and then we're going to add 1 to the street number every single day, that means every day you're going to be living in a new house, right?
Yeah, and I'll keep moving farther and farther away from the house I was originally at.
Exactly. So if we were to take our simple line of code right here and embellish on it, let's go ahead and write up here a little bit, maybe right about there. Let's say we did something like E dot L. Now I'm just going to write L. In your mind, viewer, please think that I am typing out the entire word left. I'm just trying to speed up my whiteboard process here. So E dot left equals E dot left plus some number. Let's just go with 1. And then we'll terminate it because that's the end of our statement. Every single time this line ran, what would we get? We would get a box that started, then it moved over, then it moved over, and then it moved over, and it would continue to move in the direction right, so in the right direction, because we are incrementing, got a plus right here, where it's at. If we would have, instead of used a plus, if we would have used, let's say, a minus, I'm just going to put that in parentheses, so if we would have used a minus, we would have had an object moving this way because its location number would have been decrementing, okay? So it would have been decreasing. So that is kind of what we're going for. Now, to put this all into perspective, we're just going to jump back over here into Delphi. And Logan, what I want you to have happen is every time the timer fires, which to start out with is going to be every 1 second, move that guy 1 pixel.
All right. So going into our timer, doing pretty much exactly what we've just seen on the whiteboard.
Before Logan goes any further, again, I want to make something very easy to see here. Can you go ahead and delete that procedure out?
Yeah.
I want to show them this.
This will take care of it and clean it up.
Okay, check this out, guys. Let's come over here. This is all of the code right here by default when we start out with a brand new program, a VCL-based program. That's all the code that we have in our main unit, all right? Now, back over here on the designer, when we come over to the events section and we double-click, I want you guys to watch this. So here we are in code. I'm going to double-click, so focus on this. We have nothing that says on timer. So here I go. Double-click. It looks like it took us to a new area, but it did not. If I scroll up, there is everything you guys saw just a second ago, and then right before the end of this unit, it added this little section right here. We also got this a second ago when we were over here on the designer, and Logan double-clicked on this because, as we told you guys in an earlier episode, generally when you double-click on a component, the default code, or the area that your default event, the area in which you are most likely going to write code is what is created. So that is what happened when Logan clicked on that, and you guys can see I also got to it by simply double-clicking on the on-timer event. So now if we go back into code, whatever code we type between this begin and this end will get fired on every interval of the timer, or executed on every line. So what kind of code do we want to write? Well, the goal is to simply move our box from left to right. So the box's name is enemy, so we first call it by its name. And then we tell it dot, what property are we going to talk to? We're going to tell it left. Now we need to assign some value into that. So we're going to say colon equals, and again in a previous episode we said in Object Pascal, colon equals is our assignment operator. Now what is it going to equal? It needs to equal where the enemy is currently at, plus, and we'll just put 1 for now, and we'll terminate it. So this means move 1 pixel over. So that means every time the timer fires, the enemy is going to have its left property incremented by 1. This means, Logan, he's going to move so slow, it's almost going to be hard to see.
I know, it's because the problem is he only moves once a second. So
exactly.
A lot of time goes by before he actually moves.
So let's go ahead and jump back over to our designer, or we don't even have to jump to the designer. Let's go ahead and run it just so that they can see. So Logan ran it, and if you really watch, he's moving. You can see he's getting further away from the starting point.
Yeah, I'll put the mouse right by it so you can see.
All right, here it goes. He's about to catch up with the mouse. Bink. Bow. There he is. Okay. Now, how can we make him move faster? Well, there's a couple of approaches. One, instead of saying +1, we could say +2, +5, +10. And he's going to jump 2 times faster, 5 times, 10 times. But that's the key. He's jumping. It's not going to look quite as smooth, right? So how about we make the timer run that code more often? So instead of firing off the timer's event every 1,000 milliseconds, or every 1 second, let's fire it off every 500 milliseconds as our first example. So that means we're going to fire off every half a second, so it should move twice as fast. So we'll come over here to the interval, change that to 500, and go ahead and run it. So Logan hits F9 again, and if you watch, it's still moving slow, but it is indeed moving. It's moving faster. Now let's go ahead and close our application and take our interval and up it to something a little more interesting. Let's up it to like 5. I bet that's going to be noticeable. We have a moving character, ladies and gentlemen. But, resize it, quick. He's still there. He didn't go away. He's just going forever to the right, as you guys can see there. Now you can see why I didn't want Logan to lock down the size of the window yet, so that the user could not resize it. We'll do that at the end. Well, that's all nice and dandy, Logan, but we demonstrated it moving. But how about we make it a little bit more interesting? How about we have it when it gets to the end, it flips back to the beginning. Now this is going to bring us into something new. Oh boy, here we go. Bringing up our whiteboard. Ooh, that's kind of scary looking. Let's go ahead and delete everything. We need to get into a scenario where we can use the if statement. What is the if statement, you may be wondering if you're new to programming? It is our ability to do some sort of conditional test and make a decision based off that test as to what code we're going to execute. And in this case, with what we've got at the moment, we're simply, I'm going to just draw a quick little lazy circle. That's going to be our enemy. We're going to keep checking over and over and over until he's reached the end of the form. And if he reaches the end of the form, what we want to do is reset him back here. So it's going to look like he's going to go all the way off the screen and then warp back. That's what we want to do. So we need to set up a simple test. Well, to do this, we will use what's known as an if statement. Now, let me give you a real-world example. Let me think. What's a good example? I know. Do I want to go outside today? Well, it depends on the weather. Okay, simple enough. So here's my thought process. I'm cruising along and I decide, hey, what do I want to do today? My big question mark. And I have 2 different scenarios. Whether I'm going to stay inside or I'm going to go outside. So I'm going to do a little flow charting here. I'm going to put this inside a diamond. Okay. And we're going to say that I'm going to stay in. And we'll say go out. Just have faith in me, guys. And for those of you that know what I'm doing, you know how to fast forward the video. Okay, so this is a little decision block right here. So what is it that we're going to be deciding on? Well, it's going to be the weather. All right, so now I can come down here and I can start writing out a piece of code. If, you know what, thinking about that, let's go ahead and back up just a little bit and write that a little bit higher up. I'm going to say if the weather dot, and let's say it has a property called sunny. So if the weather dot sunny equals true, that means it is definitely sunny outside. Then, now I can tell it to go outside. Else, stay inside. All right, I know that's not the prettiest in the world, but check this out. Let's come back up here, and we're going to say that this is false, and this is true. Now, real-world example in application. I'm thinking, what do I want to do today? Well, it all depends on the weather. Okay, let's check the weather. Is the weather sunny? If the answer is true, which you can replace with the word yes. If it's sunny outside, yes it is, then I'm going to go outside. So then we're going to go outside. If it's not, false. If it's not, then it's false. We're going to stay inside, right? Stay inside. That's where we hit else. So if it's not true, instead of doing this line of code, we're going to do this line of code. Make sense, Logan?
Yeah, I mean, it's just a very simple, it's a decision based on a condition. And the whole idea is to be able to branch exactly what you're doing, branch your code flow based on something. It all boils down to making decisions.
Exactly. So let's go ahead and delete all of this and talk about how we're going to do this in our programming world. We've got an enemy, and we've got an enemy that has a property called dot left. And this enemy is running across the screen, and we can check that dot left against the width of the form. So here's our form, and you know what? I'm going to come over here and grab the shift button and just make some quick lines real quick, like such. So we have a width, and the width is going to go from here to here. And let's say the width is something like 100 pixels, right? So all we need to do is keep checking the dot left property. So enemy dot left, so E dot left, that is an E, I promise. And as soon as E dot left becomes 101, that means he just appeared right here, right? He just went right outside the width of our form. Then all we need to do is set that back to 0 so that he would then appear as if he teleported back over here. That's the goal. So we could write something real simple like if E dot left is greater than, I'm just going to, real quick, form dot width, then, now I'm going to put all this on one line just to make it easy to read. Then what are we going to do? We're going to say E dot left equals 0. Look good to you, Logan?
Yeah, just a simple position reset.
So there you go. Here's our test condition. Okay, as I draw out. So if that test comes back true, then we're going to do this. If it doesn't come back true, it's not going to do anything, period. Now, when Logan types his code out in just a second, keep a very close look at the if and the then when he types them. They're going to appear in a dark blue. That means these are key words for Delphi. They are reserved words, meaning that you can't create your own variables or your own procedures, functions, etc. That are called these words. You can't have a procedure called if or a procedure called then. Delphi is going to go, So keep an eye how you'll notice that the coloring in the ID is special color coded for keywords. All right, so now that we know what we want to do, Logan, go ahead and jump on over and let's code that in. So how do we do this? We're going back to our timer.
So we've already incremented the location. Now we need to do that check to see if we need to screen warp.
Okay.
We'll say if, and
you'll notice it brings up a little helpful thing to kind of help you out in remembering how the condition's laid out, and Logan just got rid of it, which is okay. Logan doesn't usually use it, but it works exactly how he's about to type.
So we're checking enemy.left, see where the enemy's at. What we're looking for is the enemy to go over the width of the form. So we can say form1.width. Then we needed to reset the enemy, so we'll say enemy.left is equal to 0.
Again, the assignment operator is :equal. So we are, in this particular case, what we're doing is we are putting a 0 into the left property of the enemy if the enemy's current position is greater than the width of the form. Meaning, as Logan just said, we're simply resetting our enemy back to the left-hand side. And this, again, this is going to get fired every 5 milliseconds. Again, this is our timer. Remember, we've got our timer object selected. So, Logan, let's go ahead and run the application and see if it works. So enemy. Yeah, it's our cool song for the day. And rip. Look at that. He warps from one side to the other. Simple enough. Now, you know, we've been doing left. We can do up and down just as easily, right?
Right. I mean, we've got the top property, and as we discussed before, that's like Y, which is like up and down.
Go ahead and, let's say, set the enemy to 0, 0 for left and top real quick over on our designer. So there he is, 0, 0.
There we go.
All right, cool. Now, change your code around. Show them how easy it is to change the code that it's going to go up and down instead of left to right.
So to move up and down, we'll change this to say the enemy's top is incremented by 1. And then if we want to keep the screen warping in from top to bottom, we need to change these as well.
But now we're no longer checking the width of the form, we're checking the height.
Yeah, exactly. I had mine getting fuzzed here.
No, he was right. Enemy top. It's the height of the form we're going to check.
Oh, yeah. Yeah. Just
so
keeping up.
The form's height. Then we'll just simply reset the enemy's top back to 0. That easy. And if we run this now, watch what happens. So now he's going from up to down. So you can see how manipulating both the left and the top property allows us to reposition an object all over our screen. Very, very cool indeed. Okay, so let's keep all that in mind, and let's go and close the application. So now that we have an enemy, you know what? Let's go ahead, Logan, and rename our timer. Instead of calling it Timer 1, how about we call it Enemy Timer? Because it's now going to be in charge of making our enemy move. Do you see, viewers, how we're going in there and we're now starting to control the name of these objects so that in code they make sense? Doesn't it make so much more sense right now when we come into code? When you see something like the enemy's top, you know you're dealing with the enemy's position. If instead it would have said something like shape 22 top, we wouldn't have necessarily known what box was getting messed with, right?
Right, and you'll end up spending more and more of your time hunting through objects just to find something to work with.
Precisely.
Whereas if you've established names and you think, I want to move the enemy. Well, okay, enemy dot, and then talk to it.
Exactly. And if we were to come back over here to the designer real quick, it makes our structure dialog become so much more useful over here because now we have objects that make sense to us. And I like that. It's very important, and it's just good programming. All right, so now that we know we have the ability to make an enemy be controlled by time, let's go ahead and introduce a player.
One last thing, as we're locking down the enemy timer, I'm going to set its interval to the final interval we use in the game. We've, of course, messed with this, and we found that 30 to work quite well. Okay, and of course you guys are free to play with your own numbers and come up with crazy stuff. But now what we're going to do is put another shape into the screen. So here's our shape, and here it is on the screen. And let's go ahead and make it 32 by 32 in regards to width and height. Whoa, that's big. All right, 6,000. Yeah, now keep that away from him. That's going to be very challenging. Okay, so now that we have that in place, let's go ahead and name this player so that we keep with our naming conventions. And I know if there happens to be any skilled programmers out there watching this, they may be mumbling a little bit about the names that we're giving, because while they are simple names, there could be a little bit more information thrown into the name, but we'll talk more about proper naming conventions a little later. Do you agree, Logan? Yeah, without getting deep into control types, the prefixes wouldn't quite make sense yet. Right, and I really want to keep this as simple as we possibly can. So we have a player. Now, this time around, I don't want the player being controlled by a timer, because then the game's all automatic. There is no interactivity between the player of your game and, well, the game itself, the player that is on the screen. So what we're going to do is we're going to show you guys how your mouse can move this object around. All right, and there's the two key words are mouse and move. That's right. You're going to find that we have a
a mouse move event, don't we?
If we look at the form's events, under input, we have a lot of mouse events, one of those being mouse move.
Okay, so basically what's going to happen is this mouse move event for the form, because that's what's being selected at the moment, will basically fire every single time the mouse is moving. So as I move right now, it's being fired, it's firing over and over and over and over. So all we need to do is reset the position, both top and left, of our player right here to wherever the mouse is every time the mouse moves in the on mouse move event for the form. Okay, so we can just simply go in here and double click. Now we've got our code. Again, it's not a whole new thing. We're still inside of our main unit, right? Logan, let's go ahead and start typing. But well, actually, before we do that, we need to take a close look at the layout of this procedure, because this is it's a little special. For us to place our shape, our player, exactly where the mouse is, we need to find out where the mouse is.
Right, because before we were just incrementing.
Right.
Now we need an exact location. So you might be thinking, well, how do I read the mouse's position? And in this case, we don't need to read the position ourselves. Because of this mouse move event, we are fed, if I scroll over a little bit, among the other things we're fed, we're given an X and a Y value. So we don't have to go look for anything. The information about the mouse is given to us already.
Now, in case any of our beginners are starting to hyperventilate right now and think, oh, that's very confusing, I'm going to say the following. Yes, it is. What's happening is when this procedure gets fired right now, we get some information populated for us that we can access. Okay, we have things like an X, a sender, etc. Okay, that we can access, and in this particular case, this stuff is going to become important to us. You'll notice that we have information sent to us, and pretty much every event that gets fired, like let's look at the timer. Every time the on timer event happens, we have information that gets sent to it. Okay, it's called a sender. It's of type T object. I am hoping that right now, if you're a beginner and I'm talking what sounds like gibberish to you, that's the case. It sounds like gibberish because it shouldn't make any sense. I want you to have faith in us right now, because we're going to start getting into all of these types of parameters and variables a little bit later. I just want you to note that we have access to this information inside this procedure that we can now use. And in our particular case, we're interested in that X and Y that Logan just showed you. Okay, Logan, so with that, and them just having complete faith in us, let's see what we're going to type.
Well, we're moving the player around, so we'll start with player.
Okay.
We'll start with his left. Yeah.
And left, as I said a second ago when I was drawing on the board, is kind of like X, back and forth, right?
Well, and then that's a very good comparison to have in mind, because that's exactly what we're going to set him to. We'll just say player left. Yeah,
okay.
Player.left equals X.
Okay, now let's go ahead and do player.top, and since that's like up and down, it's like Y. All right, so let's go ahead and run our little application real quick. And look at this.
So, wow, for a big, long discussion, that was actually a fairly simple amount of code.
Very, very cool. But you know what? Looking at that, you may be thinking, oh, it doesn't look too great, because right now what's happening, actually there's two problems that's happening. Number one is the mouse is in the far upper left-hand corner. That doesn't look that great. It would be a lot more interesting if the mouse was in the center, or the player itself always stayed center, yeah, like that. Another thing is, as Logan carefully moves the mouse around inside the player, look at this. Is he just kind of, yeah, the player's not moving right now. And why is that? Well, that's because the shape object also has a mouse move event. So right now, with the mouse inside here like this, a different mouse move event would be getting fired. Instead, we need to make sure the mouse move event out here for the form is getting fired. So as long as we stay in here, no movement. And we can fix that and the centering both relatively easy. Let's go ahead and fix that problem first, because all we need to do is just disable the shape.
Right, because what's happening is, like you said, if we look at the shape, look at its events, it has a mouse move event. That means that he's getting in the way and grabbing that event. He's intercepting that event, and it's not getting sent to the form, which is where the real move code happens.
Right, and in case you're wondering, well, why, instead of putting the real code for controlling it moving around with the mouse on the form, why not just put this in his event? Well, if we put this in the mouse move event for the shape, what's going to happen is the X and Y information you're going to get is going to be based off the shape of this thing. So it's going to start with a 0 and only go over 32 pixels. Now that means if we were to do that and use the exact same code, we would stay hugging this area right here. We really wouldn't go anywhere.
Right, because we only have 32 pixels to move in either direction in that shape. So you're restricted to that one little 32 square up at the top left.
Now, of course, you could make the code a little bit more sophisticated to then take that and use that as an offset with the overall width and height of the form, but now that's getting too complicated.
And even if we took that trouble, there's still other problems. If you move your mouse really fast, you can get the mouse to jump out of the player.
Right.
And if now you're out of the on-mouse move event area and you're not moving the player anymore, you've dropped the player.
Exactly. So the simplest approach here is just to simply take this object and go over here to the property that we talked about at the very beginning of this video. Remember how we can enable something? Let's disable it. So we set enabled to false. With this disabled, that mouse move event will not get fired.
Right. He's no longer looking for mouse move. And what that means is that the mouse move will fall through down to the form, which is where we want the event to happen anyway.
All right. So let's go ahead and hit play now. So we'll run our application, and Logan's moving it around. Of course, we still don't have it centered, but look at this. I'm going to try to carefully move the mouse around inside the box. I can't. Now it's nice and smooth looking. Now, we need to go ahead and take care of centering this thing. Now, how do we do that? All right, Logan, let's go ahead and stop this, and I need to jump over to the whiteboard for just a second.
Hang on, and we're good.
Okay, so coming over here to the whiteboard. Now, I'm going to try to keep this as simple as I possibly can because I don't want to scare anybody. Now, right now, what we're doing is we're finding the location of the mouse. So, again, this gives us both an X and a Y coordinate, and we are setting our box to that location, which means the box, the top left tip of the box, is then placed or anchored right like such. But what we want instead is the box to be in the center like this. So look at this. This means we're going to have to move it up some, and we're going to have to move it over some. But how far? Very, very simple mathematics will allow for this to happen. What we need to do is we need to take into account the width of the box, and we need to take into account the height of the box. And then if we simply divide that number in two, wouldn't we end up getting the center? Do you agree, Logan?
Yeah, because if the box is 32 pixels wide, we divide that by half, we're now looking at 16 pixels. We move it over by 16 pixels, we're now centered on the mouse cursor in one direction.
Exactly. So
we do it again in the second direction, then we're completely centered.
Exactly. So to do this, all we need to do is tell it that our player, so we're just going to call it P instead of E now because we're dealing with the player. So our player's left, and I'm just going to abbreviate, guys, but remember in code you can't just say P.L. That's an error. We need to type the whole thing out. So the player's left is going to be equal to, and now here's where we can tell it it's going to be equal to X. That's what we've got at the moment. But now we can subtract. Why subtract? Because which way and left are we moving? Are we moving to the right, or are we moving to the left? If we were having to move it to the right, we would want to add. And since we know we're moving it to the left, we know we want to subtract because to the left is back towards 0. So how far do we want to subtract from this? Well, all we want to do is we want to take the player's width. I promise, that's an H. So we're going to take the player's width and divide it by 2. Remember what I said just a second ago. We're going to take these and say divide by 2 and divide by 2 to get that center. Now, divide in Delphi, we're going to use div 2. And then, of course, I'm going to do a terminator like such. All right. Now, with that, this right here will actually shift our box over so that in regards to the left, we're centered. Now, all I would have to do is the same exact code again, player.left equals, Y minus, and then again, it's just the same thing. It's going to be player, but this time we're looking at the player's height, and I'll just put H, divided by 2, like such. And that's going to take care of centering.
I was going to point out top for a player.
Oh, I'm sorry. Yep. You did it a second ago. I did it now. So easy to do, because now we're dealing with up and down. So player.top. I hope you viewers out there caught that too. I'm just talking at 100 miles an hour, and it happens.
We're just seeing if everyone's paying attention.
That's right. So this right here will allow us to center up our box, and this is the reasoning why right here. So Logan, go ahead and take us back over to Delphi real quick. And we can close the game out.
Yeah, I just noticed that there. I was
running.
I was thinking that was something else.
Okay, so let's go ahead and all we got to do is jump back into the code, or go back to the code at the bottom is good.
So down here.
Or code, either one. So we're back in the, and I'm going to start making us make a habit out of this. When we jump back over into a procedure, I want to show them where we are. So we're back into the forms mouse move, okay? Now, a second ago, Logan was just setting the X and Y, but now let's go ahead and account for the width and the height of the player.
All right, so we've got X, but this is causing us to go, we'll have the left edge of the box, and we want to do our offset. The offset we talked about was by subtracting the player's
width divided by 2. Very simple. And we'll do the same thing on the next line. The player's height divided by 2. All right, so let's go ahead and give this a try. So we'll execute it. Ooh, nice and smooth, and the mouse is now in the center. I like it, Logan. I like it a lot.
It's smooth looking, because before, with the choppiness, that would throw you off because you would see the chop.
Right.
With the box being synced to one side, it made the entire control feel off-handed because you had the player sticking to the wrong side of the mouse.
Precisely. Okay, let's see. On our voyage to create an amazing game, what can we do next now that we have the ability to control a player? I know. How about, at this point, we go ahead and throw some simple collision detection in there. I want to be able to tell if two objects have interacted with one another, if they've touched one another. Now, we can, in a second, I'm going to show you how we can get over into the world of the help file and find the function we're going to use. But first of all, just a very simple demonstration here of what we're looking for. We have a player that's going to be running around. Or excuse me, I'm going to say enemy. And we have a player that's going to be running around. And the goal of the game is to make the enemy chase the player and try to get the player. And we're going to show you how to make that very simple AI code in just a minute. But first, let's do the collision detection. I want to know if at any time any part of this shape touches this shape. Now, we could do a series of tests where we could say, take the left edge of this edge and compare it with the left edge of this edge, and then also compare the top of this edge with the top of this edge, and we can make our own little algorithm to determine if the two are overlapping in any way. Phooey on that. It's built in. We actually have a function available for us. This is another area where I ask for you guys that are completely new to programming to take a nice slow sip on your coffee and have faith in what we have to do to use this function. Logan, let's jump back over to Delphi real quick and show them how they could have found this particular code. We want to check to see if we've got two boxes that are going to intersect at any point.
Well, if we want to see if there are any functions available for intersecting, I'll first jump down to Win32 stuff, and let's just see what they have for intersect.
Intersect. Ooh, intersect rect routine. Well, let's click on it.
So go to the types variant of that, the first one that shows up.
Calls intersect, let's see, returns an intersection of two rectangles. Hey, and we're dealing with two rectangles. Call intersect rect to obtain, let's jump over here, there we go. Call intersect rect to obtain the rectangle that is the intersection of R1 and R2. The intersection is returned as rectangle parameter. See, intersect rect returns true if the two rectangles have non-empty intersection. In other words, if they are overlapping, and it's going to return false if they're not. Now, this is the function that we're going to need to use. This is probably going to be one of the most complicated looking things that we've done and are going to do in this entire application. Wouldn't you agree, Logan?
Right, just because everything after intersect rect is probably going to look cryptic right there. We have a bunch of symbols. We have things like out. We have everything, things like out, var, and a lot of odd-looking stuff.
Exactly. But what's going on here is really pretty simple. What happens is it's a routine that is built into Delphi, and we are built into one of the libraries that we're using in Delphi. And with this, we feed it rectangle 1, we feed it rectangle 2, and what happens is it is going to output for us another rectangle. And that other rectangle will contain the proper coordinates for any intersecting area between those two rectangles. So if those two rectangles happen to overlap, let's actually, hang on guys, let me jump back over here to my whiteboard. So if we do end up in a scenario where these two guys have touched, see that little rectangle right here? That's the information that's going to get fed out in case we want it to do something like that. But we don't. In our particular case, that is not interesting to us. What is interesting to us is the final output of this function. It's going to return true if there was indeed some sort of intersection, and it's going to return false if there was not. Now remember, a minute ago I gave you guys the grand if example of if I want to go outside or not based on the condition of the weather. And remember what I said? If the weather is sunny, and how did I say that? If weather.sunny equals true. Boolean is true or false, yes or no, on or off, 1 or 0. That's a Boolean, okay? It's just basically a toggle. So Boolean is true or false. So this gives us a true or false. We're going to set up the same kind of if statement. If it's true, then we have just collided with the enemy. I hope that makes sense. If it doesn't, have faith. Type this out, and in the future, when we get deeper and deeper into these functions, and I'm not saying future like in months, I'm talking future as in this week, this is going to become a lot more clear to you. So Logan, let's go ahead. Now that we see how this works, and we see it's called intersect routine, what we can do is go ahead and use it. Let's jump back over here and do so. Now, where is the most logical place where we can put the collision detection? If I may, right now, we have an enemy timer event. And as a quick recap, this event is fired every 30 milliseconds. That's what Logan put in just a second ago in the interval. And right now, we are using the code inside of it to move the enemy. Well, that's a fantastic place to also check to see if we've just collided with our player. It's the most logical place to put it. So Logan, let's go ahead and put our collision detection code in here.
So like you're saying, we need to make a decision because we need to decide if we have indeed collided or not.
Right.
So we need to begin this all with an if. And what we're checking for is to see if intersect rect. I'm probably not going to talk as I type all this or I'll trip myself up.
That's fine. We can enjoy a few moments of silence from all my typing.
So we're using intersect rect to do the check and turn some rectangles into a simple on or off value we can check against. Now, of course, it's going to take in that extra rectangle thing, and I'm going to call that overlay.
You'll notice the little tooltip pop-up at the bottom is highlighting or bolding the section in which you're typing at the moment. Okay, so right now he's on the second parameter, and this one is a rectangle. It's rectangle 1, so what we need to do is take a look at player or enemy.
Yeah, we'll say that the player is going to be our rectangle 1, and the property of player will be its bounds rect. We'll let it give us a rectangle of where it's at.
Yeah, the bounds rect returns us that rectangle information.
And finally, we need to compare that with enemy. So we'll grab enemies bounds rect.
Okay.
And close that. And you can see it's jumping a little bit off the screen.
That's
here,
okay.
But we do in fact have our then in place. That's what's important.
So if all of that results in true, then we need to do something. For the doing, let's go ahead and hit enter, because we can jump down to the next line, and that's inserted a little bit just so that it's tabbed in, it's offset, so that makes it kind of clean to see that this code belongs to that if statement. So what are we going to do? Let's just do something simple, like a message box that says you are dead.
Sure. So we'll use show message to do the message box, and just say you are dead. Like so.
Okay. Now, right now you'll notice that we have the word overlay underlined in red. We have a problem with it. That is because overlay is a variable that we have not defined, and this is something, again, we're not getting into variables in this lesson, but we have to use a variable in this one place. So, to define the variable, we're going to go right before the word begin, and we're going to type in the keyword. Notice how it's dark blue, like I talked about with the word if and the word then. And now we're going to define our variable. It's called overlay, and what type is it? It's of type T-rect. Because remember, if the two triangles do indeed intersect, a rectangle is returned. That's the data type. So that's T-rect. I know it sounds like I'm talking Greek, but it's going to make
that
more...
was cryptic. But wait, this is no longer an error.
It's no longer an error. This is going to make more sense later. So that's it. That is our simple collision detection. So let's do two things. Let's first demonstrate it, and then let's talk about comments.
Okay. So I'll run this, and...
running around, and when we bump into him, up, you are dead. Okay, but of course he keeps running, and we can click OK, and we've got a bit of a problem, don't we?
Yeah.
Had a bunch of OKs because as he continued running through it, look at that, fire. We have a whole bunch of, you can go and click through them all. Yeah, there you go. That was cool how you moved the one out of the way. And quickly get out of the way. Quickly, you can do it. You can do it. You can do it. You can do it. Oh, now there's a whole bunch more. Keep going. Almost there. Almost there. Almost there. Almost there.
Could just jump back into Delphi.
I know, but hang on. You can do it. You gotta beat it. You gotta beat it. You gotta beat it. Beat it. And nope. Okay, not gonna be able to beat it. Ah, that's all right. We'll come back over here to Delphi and we'll just tell it to jump out. All right. So obviously we need to take into account that being hit over and over and over. So we can. You want to just go ahead and tell it stop the timer here?
Yeah, because if we're dead, then we'll say that's it for the game. The game ends when you die.
But this means we need to do more than one line in this if statement, right?
Which means we need to make our if statement a little bit more advanced.
So if we're going to do more than just one line in the if statement, we need to tell it to begin. And then we can jump down to the very end and put an end in there. There we go. It did it for us automatically. Now we can type multiple things to happen if that test is true. So let's go ahead. Before we even show the message box, let's kill that enemy timer.
There's our enabled property, which we'll set to false.
Now let's run her again. All right, so we run around all happy, and as soon as there's a collision, look at that, you are dead, and the enemy stopped moving.
And that, in turn, stopped firing off the event, so we only have one of these message boxes.
So that's the importance of enabling and disabling objects. You can see how handy that is. So at this point, that object is not going to fire any more of those on-timer events until we turn that timer back on. All right, so with that out of the way, let's go ahead and click OK. Let's close the application. Now, let's introduce them to comments real quick.
Okay.
What is, and we're just going to talk about single-line comments right now. What is a comment? Well, as you start typing more and more code in creating an application, you may find yourself writing more and more logic that can be confusing to somebody that comes in behind you and looks at your code. Or, better yet, I love this example, or you may write something that's really just ingenious at the moment, some crazy logic, and then you may walk away from that program for 3 or 4 days, come back to it 3 or 4 days later, look at your code, and think to yourself, what the heck was I doing? And not exactly remember what the code was doing. Because sometimes just looking at code doesn't mean you're instantly going to understand it, because it may be part of a much bigger picture. Well, fortunately, we have the ability to leave comments or remarks or notes for ourselves or for anyone else that may come in and look at the code later. And this is very important. Using these comments help basically create documentation for what's going on with the code. Now, to do a single line comment, it's very simple. Go ahead and show them, Logan.
All right, I'm going to space this out just temporarily so we have some space to work with.
And we'll just do 2 forward slashes. And now you'll notice how it is now color-coded yellow. So this is our collision detection code. Well, okay, that is a comment, exactly.
Very good.
Now we're going to put a real comment in.
This is the... So we've got this noted as our collision detection code.
Now when the compiler goes through, and we're going to talk more about compiler and that fancy type stuff later, but when the compiler turns this into an executable application that runs, anytime it comes across comments, it simply ignores those. That's why they are highlighted in yellow. The idea is just to let the programmer have a means of leaving comments in the code for himself or someone else. And so at this point, let's go ahead and clean that part out. This is a comment, and we will start using comments throughout our code to help document stuff.
Right, just to reiterate one last time, you've seen so far everything we've typed has been important. It has all meant something. Anything that has not been meaningful has not been allowed, like overlay. Before we told it to allow that, we couldn't get past that. You can't just drop down words into a program. Those words aren't going to be ignored unless you mark them as a comment. Then you're free to write about stuff all day long.
Precisely. All right, so right now, let's go ahead and run our program again, and there's one more problem I want to address. When we run into it and we die, go and click OK, we can still move our character around. How do we stop moving our character around? I hope you guys by now have realized the way I'm presenting this I'm presenting this in a way that it's basically small problems we're solving. And we're just working through each solution, and as we do, the bigger picture, the game flea, gets created. So right now, when we die, we want our player to stop listening to the mouse. So a logical approach to this, what controls the mouse moving around? The player moving around. Right here, the form mouse move event or procedure that's called as the mouse moves over the form. What if we were to enhance our code inside this just a little bit, right in here, such that we first check to see if the enemy timer is running. Because if the enemy timer is running, that means the enemy is moving. That means we should be able to move too. That's only fair. But let's say the enemy stops moving because he just collided with us. If we turn the timer off, which is something we are doing, remember we just did it right here. Enemy timer enabled, false. We turned it off. How about we stop ourselves from moving? So all we need to do is an if statement and put this stuff within the if statement.
Okay. So we'll start our if by saying if enemy timer dot timer. Is that right? Yeah, I had it right.
Enemy timer, yeah. Dot enabled
is equal to true. And now I know there are more concise ways of writing this.
Yeah.
But this will make the most sense for what we built
for
so
a beginner.
Far. Wow.
As long as Logan can get the word true out. There we go.
Like I said, I cannot talk and type at the same time.
Exactly.
There will be words or letters and won't be both.
So now we want to do two things. So since we want to do more than one thing, we need to begin after the word then. And we can go ahead and move both of those in. And we need to make sure our end is in place. There we go. So now when the timer gets turned off because of a collision that occurs, when we move our mouse around, we're going to find that the timer enable is false, not true. And since it's false, we're not going to do this section.
Right, we'll just skip right
only
over
do that section if it's true. Let's run our program now. So we can move around.
We are moving.
Collision.
We have died.
Click button.
And now we're not moving anymore.
Ooh, very, very simple stuff. All right, so we've got a message that you're dead and all that good stuff. So I guess at this point, as our game is now starting to take shape, player controllability, collision detection, now we need to create some simple AI, some very simple artificial intelligence for our enemy. He needs to look for our player and move towards the player. Let's go ahead and close Flee out. And I know this is going to be loads of fun, guys, but I got to come back over to the whiteboard real quick, so you got to bear with my awful writing for just another minute. How are we going to come up with this code right here? Let's go ahead and clear our screen, and it's really going to be pretty simple. We're going to have an enemy, and we're going to have a player, and we simply need to check the enemy's left and top against the player's left and top, and then go from there. So, and we're going to do this in an if statement. So we can say something along the lines of if the enemy's left position, again, I'm not writing the whole word here just to save time. So if the enemy's left is greater than, or in this particular case, let's say it's less than, because we can see the enemy's over here. So here's going to be the top of the window, right? So we'll say all the way over here is a left of 0, and all the way over here is a left of 100. Good enough. And we'll say that right here, the enemy currently has a left of maybe 10, while right here, the player has a left of maybe 60. Okay? So if the enemy's left is less than the player's left, then what are we going to do? Well, we need to move the enemy somehow. Then we're going to do the following. We're going to say that the enemy's left is equal to where the enemy is currently at. So let me go ahead and do colon equals. So his current position. And hang on, I'm just going to fix this up because I don't want anybody that may have played with C++ before and think that's 2 equals or something. Not an equality test. Colon equals assignment. Okay, so the enemy left is going to be equal to where he's currently at plus, and then we're going to put in some number. So if I just put in 1 right now. Now, how does this all work? Well, what is enemy left at the moment? It's 10. Okay? What is the player's left at the moment? It's 60. This means I need to go in this direction, right? I also need to go down, but we'll deal with down in a minute. So he needs to go to the right, which means our left is going to increment. It's going to become a larger number. So, is this case true or not true? Is the enemy's left currently less than the player's left? So is 10 less than 60?
In the drawn situation, it is indeed.
In the drawn situation, the answer is true. So since it's true, we're going to do the then part. So then we're going to take the enemy's left, and we're going to take wherever he's currently at, and we're going to increment 1 to it. That means after this entire line runs right here, where is the enemy going to be positioned? His left is going to be equal to
11.
11, because we incremented it 1. Meaning he just moved over in this direction. just a little bit. So you can see if we repeat this code over and over, so we've got if enemy left is less than, if we also had, I'm not going to write out if, but pretend this whole line is duplicated except for the following. If the enemy's left is greater than the player's left, that means we have an enemy over here somewhere. Then what we need to do is take the enemy's left, and we need to set it to the enemy's left -1 because we now need to go in this direction. Now, again, pretend the word if and then is all part of this.
So now you don't have to pretend.
Now you got the whole thing. But pretend we did these 2 lines again where we're talking about the enemy's top. If it's greater than the player's top, then again, we're going to do the same thing with moving it. And if the enemy's top is less than the player's top, we're going to move it in the opposite direction. So those 4 lines right here is all we need to generate some very simple artificial intelligence that will allow our enemy to seek our player. Agree with me, Logan?
All right, yeah, it's very simple follow code.
Okay, so let's go ahead and jump back over to Delphi. Let's write it in.
All right.
So where do we put it? That's the first fantastic question.
Well, I mean, in this case, it's simple because if we remember back to what we did before to make the enemy move, we thought, well, we had the enemy timer. We had inside the enemy timer, we set the enemy just to move in one direction by 1 every time.
So right now we're about to change our movement code to something a little bit more involved. So let's go ahead and take that top and moving part out, basically where he went all the way to the bottom and warped around. And now let's go and put a comment first. And let's say simple AI for the enemy.
Okay. Wait. Typing is so much fun. All right. So beginning with what we just talked about in the example, we're going to be checking the enemy's position. So we'll say enemy dot
Yep, got
left.
2 E's.
Yeah, got some extra E's. So if the enemy dot left is, what'd you have first? Less than or
I think I had less than. Yeah, if he's less than. You'll notice it doesn't matter what order these are typed in, guys.
Then we know that we're to the left of the player, and we need to increment. If we're, let's say us right now is the enemy, we're looking at things from the enemy's standpoint. So we're saying that we're to the left of the player. We need to increment our left to get closer to the player.
Right.
So we'll say enemy dot left is equal to enemy dot left plus 1.
Beautiful. Now, so that Logan doesn't have to retype all that out, he's just going to Control-C, Control-V, and change that to greater than.
So if we're on the other side of the player, we need to move in the other direction.
Very nice. Now let's go ahead and do the portion for top.
All right. So looking at our top, us being the enemy, being greater than the player's top, then we need to take our top and let me think for just a second.
So the enemy top is greater. That means he's further down, so he needs to go backwards. So the -1's right.
And finally, if the enemy's top is less than the player's top.
If you guys are having any confusion with this, just rewind and watch this part one more time. Draw it on a piece of paper. Put numbers down. Work it out. It's not that difficult. Okay, so now if the enemy top is less than the player, that means the player's further down the form, and then what we need to do is take our enemy and make him go down. So, some very simple AI. Let's go ahead and run our little program. Uh-oh. He's coming towards us.
And now he's leveled out, and he's coming towards us. Down, up, left, right. He's got it all down.
Yeah, so he's pretty intense. And if he hits you, he's going to kill the game.
And of course, that's still in effect. We haven't touched anything with the collision code.
Game over. Die. Try again. All right, well, try again. That's kind of a good idea. Let's go ahead and take a look at doing that as our next part of building the Flea game. How about we start right now when you're starting the application, the whole game just begins. How about let's go ahead and start making a little HUD with a start button at the bottom so that we have to start the button for the game to begin.
Okay. So
let's go over to our designer and let's throw a panel down on the bottom or something.
So back up to top where we have panel.
So a T panel, and we'll set the caption to nothing because we don't need any text in it. And now this next part is an alignment part. This is important. Watch this.
So aligning to bottom. It's a really easy way of sticking it to the bottom of the form without having to manually move stuff around.
Right.
The height I want is 42.
Okay, very cool. Now, what do we do next? We want a start button down there.
So we will make a button.
And we'll set the caption on it to something like start.
Matter of fact, I'm going to name it as well, since we will need to eventually refer to this.
Right.
And that, conveniently enough, catches the caption as well.
Okay. So, good deal. Now, how is this going to work? Well, real simple, actually. I propose that we disable the enemy timer when the whole thing starts. All we need to do is select the enemy timer, and in its object inspector, set enabled to false, like Logan just did. Now, when we run our application, watch what happens. Nothing. Our enemy doesn't move because the timer's disabled. The player doesn't move because as you move the mouse around, it checks that timer and sees that it's disabled, so it knows not to move the player. So the whole game is just froze. So let's make it to where when you hit the start button, our player is now going to come to life and start moving. The whole thing's going to come to life, which basically means all we need to do is enable that timer.
So enemy
timer
dot enabled set to true.
Very cool. All right, so let's try it out. So we hit start. Ooh, the whole game comes to life.
Yep.
Now, notice the start button is still active in the bottom. It's still enabled, meaning you can get down there and hit start again, even though it doesn't really do anything because the timer's already enabled. We don't really want that. That doesn't really look good, right? So let's go ahead and close this, jump back in, and after we set the timer to true, now let's disable our button, which is called start. That's its name. So start.enabled.
Hang on.
Colon equals false. We're going to disable it. All right, that turns it off. So let's go ahead and run our code real quick.
I'm going to set it up before enemy. Just to have the very first thing is the button gets disabled.
So you click it, it turns the button off, turns the timer on. All right, so here we go. Tink. Ooh, can't hit button no more. It's disabled. Now that means, as we continue to enhance the game, that when you die, we'd like for players to be able to play the game again. So we need to be able to re-enable the button. So let's go ahead and jump back in there.
So, all right, you were saying after we're dead. Yep. That occurs. I mean, just glancing, you can glance where we have
go ahead and highlight the
message.
Procedure, show them where we're at. We're back in the enemy timer.
That was found under enemy timer. From there, it's found within our test where we test for intersecting rectangles. And then finally, we're here with the code that executes when we die. So after we're dead, we want to re-enable the start timer so we can begin everything over. So we could say start.enabled is now equal to true. So re-enabling the
Now let me
timer.
get you to do this. Go right above the enemy timer.enabled colon equals false. Yep, and put a comment right above that line that says that the enemy caught the player. So we know that this is our death code. So making use of these comments. Very, very important. All right, so now that we've got that in place, let's go ahead and test it. So start, it disables. Boom, you're dead, and click OK, and now we can play again. But that brings us to our next problem. Now we're going to be instantly dead, insta-dead, every single time because our player and enemy are now overlapping. So we need to go ahead and reset their positions. So with that, let's go ahead and set it up so that when the game begins, they're set to the proper location.
Right, we're getting a trend going where start causes everything to not only start but to reset.
Right.
Start will initialize the game's state.
Ooh, did you guys hear that? That's good stuff that we can use for later. Right now, we are initializing the game state when we hit start.
So we'll start with the enemies
left. I'll move it over to 0. Or to 8.
I kind of like 8 and 8. Have a nice little offset on the edge.
Yeah, that's cool.
And then enemies top will also be set to 8.
Okay.
Now for the player, I don't remember what the coordinates are on this area because I mean it's like, hey, 0 and 8, easy.
Okay.
Down here, I'm just going to take the player that we have here.
Look for the little pop-up logo we've got.
And then we've got 386 and 213. So I can jump over here and plug those numbers in by saying player.left is equal to 316 or 86?
386.
Was it 86?
I thought it was. And 213. We're about to find out. And 213, terminate, and that should fix the whole problem. So let's go ahead and hit start and watch what happens. Beautiful. You're dead. And start again. Hey!
And now we can play again because when the game restarts, we're not overlapping with the enemy.
Okay, so that allows us to completely restart the game. We've delayed it at the beginning, and now you can restart it. Wow. All right. Guys ready to take it a step further? Make things a bit more complicated? Because we got a game now. No matter what you say, we have a basic game. Stay away. But come on. We could stay away from him all the way up to the point where we need to go get some food or take a bathroom break. It doesn't get any more difficult. So let's sprinkle in some more elements to make this game a bit more interesting. How about we start off by introducing levels and an increasing difficulty level. So wait a minute. Let me scratch that. Let's think about this from a design point of view. Logan, we're building a game. We got to run from this guy. Okay, well, now we've got it to where we can run from the guy. Well, what do we need to do to make it more interesting? Well, it needs to get harder. Well, what is the best way to make it get harder that is simplistic? Well, there's all sorts of approaches. Obviously, as the game goes on longer, bombs start to appear. As the game goes on longer, the monster gets bigger. That's very easy to do, actually, and kind of funny. But how about the longer the game goes, levels, you get into different levels. So we start out at level 1, and the longer the game goes, it goes to level 2, level 3, level 4. And as the levels go up, the enemy gets faster. So at some point, what's going to happen is the enemy is going to be moving at the speed of light, and he's just going to catch you instantly. So we now know there is a for sure end to the game. You can't just sit there and go in circles until you're hungry or you got to go to the bathroom. So what do you think? Put in a level system?
Yeah, that sounds great. That way you have an easy way of tracking. You see the enemy moving faster, but you see why he's moving faster.
Exactly. And then, of course, friends can then say, I made it to level 8. Well, I made it to level 13. You stink. Oh, man, that's no fun. So with introducing this, we're about to start making use of our HUD, and we're going to have to start talking about methods of storing information, and things are going to get kind of confusing for beginners yet again. But again, I ask you guys to have faith. So let's start out by throwing a label down there on the HUD.
All right, we'll grab a label.
So a T label
goes on the HUD, and we need to change some stuff to this guy.
So first thing Logan's going to do is he's going to come in here and keep it enabled, but we're going to turn off the auto size.
Yeah, because otherwise it'll shrink down when we start to put what we're actually going to put there.
So auto size under
there we go.
Visible or visual. Now you can stretch it out. Go ahead and make it a little bit bigger. See, a second ago we couldn't change the size like that because it was auto size, meaning it would always just fit to the size of the text. Now we did that, so we can go back up to caption and type in a 1 because we're going to start on level 1. And now let's go down to the font and make it big and bold.
So we'll grab a font. We'll say that we want a size all the way up to 16 and that we want the font to be bold.
Okay, cool.
So we have our bold font. And one last thing I'm going to do
center it.
Is, that would be a good idea to center it up within the label itself.
So alignment properties. So notice how we're setting all of these properties on objects and how conveniently it's making changes to the object for us. Okay, very good. So that's now centered up. All right, now we need some way to store what level we're currently on. All right, this is where things are going to get tricky. If you guys don't mind, I'm coming back over, ooh, that's scary, to the whiteboard for just a minute. Let's clear all this off. This is where we would normally use variables. A variable is a place in memory that you've defined to store some information for a later use. It could be 2 seconds later that you're going to use it, but nonetheless, it is information you are storing. But we're not going to introduce variables in this video. So how can we be creative and demonstrate a way of storing information until you guys get to learning variables, which is coming up in the next video or two? What we're going to do is we're going to use one of the properties available to us on the object itself. Kind of cool, huh? We're going to use a tag property. So right now we saw that the label, which is, did you name it level yet?
No, I have not.
Okay, we're just going to say it's going to be called level, dot, and we see that we can set the caption. And right now we've set the caption to 1. Agreed? And we'll put a little terminator right here. And that makes a 1 physically show up where everybody can see on the HUD. Now, there is a hidden property called tag. And what we're going to do in just a second is we're going to set tag to 1. Now, notice in these two areas where we did the setting to 1 and setting to 1, Logan, do you notice the big difference between the look of these two?
You've got one set in quotes and the other one with no quotes.
Ooh, this guy has single quotes and this guy does not. Why is that? Well, a caption, the type of data, the type of information that goes into a caption is a string. That means it's alphanumeric. It has no value, if you will, by default, to an application. It's just letters or numbers that's going to be shown back to the user that's using the application. So we could have even put, as you guys saw earlier, it could just say label 1. It could say Jason Busby or Buzz inside here. It could say anything. So a 1 at the moment has no value. It's just text that's being shown. To get that true value, what we're going to do is we're going to store a 1 in the tag property. Tag property is kind of like an extra property that's on all these components that you can use for storing information in. And if you go out and get other people's components that they've developed as third-party components, you may find some of them have made use of the tag by, if you set the tag to a property of 1, this is going to happen. If you set it to 2, this is going to happen. Well, right now we're using a default component with Delphi, and there is no built-in functionality. It's just a property sitting there, and by putting any information we want in here that is number-based, nothing's going to happen. So it's a great storage facility for us. All it is, in essence, is a placeholder that we can put a number in, and that's what we're going to do. See, it's a placeholder, a box. We're storing information into it. So we're saying tag equals 1. So a 1 is then stored into here. Later on, when we advance to level 2, what we can do is we can say, take whatever is in the tag, so level.tag is equal to level.tag, check this out, it's so cool, plus 1. I could not do this line right here if I was using the caption up here. Again, notice the quotes, right? Because of the quotes, that's a string. It's not a number. It's just text. Down here, a tag contains a true number. So Delphi knows how to do math with it. So Delphi knows, take whatever's currently in tag and add 1 to it. So, well, what is currently in tag right now?
Right now,
a 1.
Yeah, it's a 1.
So if it runs this line first, then if we ran this line, well, level.tag, this area right here, this is containing a 1, and 1 plus, so this right here, 1. So there we go, some very simple math. What is the result of this? 2. That means a 2 is put into the tag. So if this line of code right here, the whole line runs, after that line runs, you'll find a 2 being stored in the property tag. That's what we're going to do. So this is the basis behind what Logan is about to do next. Now, for those of you out there that may have some sort of programming skills under your belt, you may think, well, can't you just convert the levels caption from text over to a number? Shoot, yeah, you can. And we could have kept it simple like that, but we really want to get our new programmers used to the idea of needing some sort of storage area to store information, because this is going to take us nicely into the world of variables. So we'll end up replacing all this stuff with variables a little bit later on. But right now, we're going to call this our variable. And why is it variable? Because it changes. It changes on the fly. This guy is changing as the program runs. So that is what we're going to do. So now, Logan, let's go ahead and jump back over into Delphi and implement this system.
Okay. First thing, we need to make sure that this guy is indeed called level.
And we'll set its tag, which is a couple properties down.
And we want the level to start at level 1.
Okay, cool.
So now, what do we need to do to have levels advanced? Because we talked about how we're going to store the level itself.
Right.
Now we need to have some way for levels to increase.
Okay.
Right now we've been driving everything non-player controlled with timers.
Mm-hmm.
So couldn't we just make another timer and have that timer drive our level?
Sounds good to me.
Now I'll move this over and I'll jump down to system where we have timer and put a new one on the form.
Wow, so a brand new timer. So we can have 2. How cool is that? Let's go ahead and give it a name.
Something that makes sense, like level timer.
Okay. That means he's also going to fire how often we set in the interval. So what do we want to set our interval to?
I'll set it to 3,000, so we advance a level every 3 seconds.
So every 3 seconds, the code inside the on-timer event for this new timer, level timer, will get called. All right, so let's do some coding. So we double clicks on it. It automatically generates our procedure, and here we go.
So when it actually fires, we want to take that number we'd stored in tag, the numeric representation of our level, and increment it.
Okay.
So we can say level.tag tag is equal to level.tag plus 1.
Wow, that looks just like the code that I just wrote over there on the whiteboard.
Exactly. It's just a matter of where to place it inside the code here.
So now, of course, our level just incremented, but visually, we didn't see it increment, did we?
Right,
because the caption is still set at 1.
We don't see tag, we see caption. So if we want to keep this updating visually, then we have to set the caption ourselves here, which would mean we'd have to say level.caption is equal to...
Now we can't just say, go ahead and type level.tag.
That's the first thing that comes to mind. Okay, well, we'll set the visual side to look like the number side.
But this is a mismatch, because if we run that, look at that. Look at the error down there. Incompatible types, a string and an integer, where an integer is just a whole number, 1, 2, 3, etc. And a string is a series of letters and numbers. It's alphanumeric characters. It's just text. So what we need to do is convert our number to a string. And Delphi has some built-in functionality for us, yet again, called int to string, or int to str. So that'll convert it for us. So now let's run this and run around and see our level increase. So we're on level 1. Oh, we got to start the game. Oh, good point. We never started out with the timer disabled. So the moment Logan ran the application, the one timer, enemy timer, is disabled, so our character doesn't move, the enemy doesn't move, etc. But we did not disable our level timer, and because of that, the levels started advancing immediately. And look at that. It is indeed advancing. How cool is that?
So, I mean, getting to level 500 is a little bit too easy here, because it's a matter of run the program and make a sandwich.
Exactly. So what I want to do is close that down, and let's start out with that timer disabled. So enabled to false. And now when the user clicks the start button, it needs to enable the level timer.
I'm going to do this. I was thinking of things for a second. I've got all the timer stuff at the bottom, so I'm going to put the level timer right along with the enemy timer. So we'll say that it is enabled when... Let's see.
You got it. True. There we go. And let's go ahead and put some code right above those 2 timer lines. So a comment that says something like, start the timers, or start the game timers. I like that. There we go. All right. So just some really interesting information. Not really. Just information so that we know later on what exactly is happening. All right. So now that we're starting it, when we die, it's not being stopped. So the levels continue to advance even though the game's over. So let's demonstrate that real quick. Go ahead and run the game. So look at this. The level 1, 2, 3, 4. It's not increasing. We're incrementing. So let's go ahead and start. Now, the longer Logan stays alive, the level is now advancing. And when he dies, watch this. It is going to continue to increment, so we need to turn it off as soon as you die. So let's go to our death code.
Death code is...
Enemy caught the player, so what's going to happen? We'll put it right up under the 1 timer. Perfect. So we kill the enemy timer, and we kill the level timer. Perfect. Now let's go ahead and test it real quick just to demonstrate that it does indeed work.
So not counting levels. Now we are counting levels. And we continue to count levels until we die. And
then as we die, we just wait. Now what's going to happen? We say, okay. When we start again, we have another problem. Watch this one. The level didn't reset, so that continues to increase. So let's go ahead and have it reset now.
Right, because, we did reset one thing. We reset the timer when we died, but we're not resetting the level itself when we restart.
Right.
So, it would seem to make sense. After we set up the enemy and the player, we start resetting our level. So we can simply say level.tag is equal to 1. Restart at 1.
Right. And then let's go ahead and set the caption as well.
So level.caption is
and
equal
again,
to...
we need to convert. Okay, yeah, beautiful. I love that example. That's exactly like I drew back over there on the board. Just put in quotes. We don't have to call a function to convert the tag. We know we're putting it at a 1. Let's go ahead and hit enter a couple of times. And then somewhere up here, put something like restart or reset the player, enemy, positions, and level. Or reset game parts or something. Come up with some comment.
Reset the game elements.
Sounds great. Okay, beautiful. So as you guys can see, comments can become very useful. Okay, so now the level should, let's go and test it real quick.
So we've got our timer. Let's just let it advance for a second so we get up to 2 or 3. And there's 3. So we've ended. Timer is no longer advancing. But when we restart at level 1. Fantastic.
All right, so this now brings us to the next thing. And what would that be? Well, our levels are getting more difficult, but play-wise, it's not getting more difficult.
Right, it's not having any bearing on the enemy whatsoever.
So what we need to do is have the higher levels affect the enemy. And how do you propose we do that, Logan?
Well, I'm thinking we take that tag we've stored in level. So we have an amount stored.
Okay.
As what level we're on.
Mm-hmm.
Right now, if we go up to our enemy's movement up here on the enemy timer, every time the enemy moves, he moves by 1.
Okay.
What if instead of by 1, he moved by whatever number we held in level? That way, harder levels would represent a larger larger moves for the enemy.
Making him get faster.
So we could replace the 1 in each of these cases with level.tag.
So guys, what he's saying is every single time the enemy does its move code, instead of moving 1 pixel, it is now moving however many pixels is the level. So if you're on level 5, he's going to move 5 pixels. If you're on level 100, he's going to move 100 pixels, and wow, he's getting really fast. So start out. So he's moving 1 speed.
Oh, now he's just kicked in, moving a lot faster. And faster.
Up.
And faster. And faster.
Now it's starting to become more difficult. Look at him vibrate. That's so awesome. Until, come on. Level 8. Well, we know Logan made it to level 8. Excellent. Very, very cool. So now we have the levels basically having a meaning in the game. The higher the level, the longer you survived as the enemy was faster. All right, very good. So now that we have this part of the game in place, I say the next project or the next mini problem we have to solve would be getting some sort of score system in place.
Yeah, so you have a very accurate representation, because right now levels last a certain amount of time.
Right.
Let's say you and your friends can all get to level 8, but you're not sure. Someone seems to be a little bit faster, and someone dies the moment they hit 8. So we need a more accurate way of telling how far you've gotten into the game.
Exactly.
And a very classic way of doing this is a score. Think back to the old arcade machines.
Yep. So let's go and jump back to our designer real quick, and let's copy and paste our level. Control-C and Control-V. All right, and let's go ahead and call it score.
So looking down from
changing its name,
miscellaneous under name, so score.
Okay, now score needs to start out at 0. So we'll set the tag to 0 and our caption to 0. Now, how do we want to make the score work? Maybe another timer?
That sounds good to me, because we want the score to increment faster than the level. It takes 3 seconds before we see any change in the level. It'd be really cool if we had the score set to like a classic old school game where the score increments really, really fast.
Yeah, she's going exactly. So to do this, we'll introduce yet a third timer. And this is going to be our score timer. And it needs to have a faster interval. So Logan's going to go with 100 milliseconds. And every 100 milliseconds, it needs to make the numbers go up. But we already know, we learned this a minute ago with level, that right now, by default, when we put that control in, when we run the application, that timer is going to automatically start because it is enabled. Let's go and turn it off. And then let's go and jump into our start code. And up under our timer game starters, you can see now that we have comments in there, it's very easy to just add in additional stuff, find where we need to go and add the code. So now our score timer gets enabled. Beautiful. And then when we die, we need to disable our score timer because we don't need the score to continue growing after you've died.
So back up to enemy timer. Underneath the collisions, we have our timers being disabled because we were caught. So
score timer gets disabled. Sweet. Now, how do we make a score actually appear? Well, let's take a look at the on-timer event for our new timer.
So I know I've just created it, but I'm jumping back here so we see.
Double-click. It's a brand new procedure it just created. What are we going to do?
Well, we incremented the level by saying the levels tag ran like such, so we could do the exact same thing for score. We could say that the score dot tag is equal to score dot tag plus some number. We can start with something simple like 1.
Okay, let's start with 1.
Now we're going to need to do the same thing where we show this, because again, tag is not shown.
It's just
caption
a number.
is shown.
Right.
So we'll have to set the scores caption to equal the scores. Hang on.
Okay.
Tag.
But remember, score tag is an integer, so we need to convert it. So int to string. Now let's run that. And start. Look at the score. Look at the score. I'm telling you, look at the score. But we can make that more interesting. That's not very arcadey looking. How about we somehow take into account the level you're on?
So that higher levels have a kind of score multiplier?
Yeah.
All right. Well, then instead of adding it by 1, we can add it by level dot tag.
Okay.
So higher levels would have a higher score. So
the longer you survive, the bigger the numbers are going to
10,
start jumping.
20, and then, yeah, already increasing a lot faster.
Now they're increasing a lot faster, even faster. But let's start dealing with some big numbers. Come on, because you get that really rewarding feeling when you play Asteroids or something and you end with, my score was 365,000. All right. So let's do a multiplier on top of that.
So multiply by, I don't know, how about 8?
8, yeah, because if you did something like 10, you're going to end up with a very round number.
And we'll have the exact same score with a 0 on the end.
Yeah, exactly. All right, so here we go.
There we go. Now we've got some big numbers. 200 before we even broke level 2.
Very nice.
And broke 1,000. And because of the level kicking in, we've already broke 2,000. Now 3,000.
Come on. Okay.
There will be no 4,000 today.
All right, well, now that we have a score, we can go ahead and do a high score, can't we?
Well, yeah, because, every time we rerun, a few things.
Yeah, we need to reset.
So it's really easy to get a high score now. Died.
So,
died.
Obviously, up under reset the game elements, remember that comment you made, which is part of the, highlight the start click. Yep, under this code right here. So reset the game elements. One of the things you need to reset is going to be the score.
And this will be much the same way that we reset level. Same type deal here. So we just say...
Again, you just copy and paste it.
And score. And except we don't want to set these to 1. We want to start them off at 0, just like we did over in the design.
Okay.
So now we have a score. We've died. And the score restarts when the game restarts.
Very cool. So now that we have the score functioning properly, see how easy this is? I know for some of you out there that are new to programming, this may seem a bit overwhelming. Just continue working with it. Have faith and keep working with it, and you're going to be surprised how quick this stuff's going to start sinking in. Now let's see if we can implement a high score. So let's go ahead and copy and paste the label. And change its name.
So this time we'll have something like high score.
Okay. And by default, when you launch the game, it's going to start out as a 0. So that's good. Everything's set up right. Now, it doesn't get reset every time you hit start. Now we need to change things up a little bit. When you die, and we get the message that says game over, now we need to take a look at your current score. We need to look at the high score, and we need to use one of those little iffy condition things. If your new score is higher than the high score, we need to give them a different message box as opposed to you're dead. It needs to say, you've got the high score, something like that. Otherwise, it just needs to say game over. So we need to go back to our death code, if you will.
So jumping back into code, if we go up to our enemy timer, we have the death code underneath the intersect check.
Okay.
And there's the where you're dead. This is what we'll replace with our if statement.
So now, check it out. We have an if statement inside an if statement. Ooh.
So this time we're checking to say if the scores tag is higher than the high scores
tag.
A little too quick with the tab there. Like so.
Then what are we going to do? Well, this is going to then begin because we're going to have to do multiple lines. Absolutely. So let's go ahead and do that. And we need to, do one or two things. So in this particular case, since the new score is greater than the high score, we need to make it the high score. So what we need to do is set the high score to the current score.
So we simply set the high scores tag to be equal to the scores tag. like so. So we've recorded the high score.
Now let's go ahead and set the caption as well. And just to go back and throw that I in. There we go.
So highscore.tag and
again we need to convert it.
Once again, int to str. So we convert the tag and store it in caption.
Okay, very nice. All right, so now we have that in place. Cool. But we need to go ahead and give them a show message.
So after this is recorded, we'll say show message.
You got the high score. Nice. Now, if the score is not greater than the high score, so if this condition right here is not true, it's false, now we need to do you are dead. So you are dead doesn't need to sit down here. Now it needs to be part of an else, right?
Right. We can take this if block and extend onto it and say else do something else.
Okay.
Which will be the show message.
So if it's bigger than, begin and make the new high score, and then tell them you got high score. Otherwise, again, guys, we're teaching if statements in the next few videos. End for this section right here. Else, meaning it wasn't true, do this instead. All right, now, why is the if statement and else statement all the way down here? Why didn't it go right here at the very beginning? Well, this is very simple logic. Logically, no matter what, we need to stop our enemy timer. We need to stop our level timer. We need to stop our score timer. Then we need to check to see if we got the high score and stuff. So these things in here will happen depending on what the high score is. And then after all this is over with, all this area here is over with, no matter what, we need to re-enable the start button. So that's what's happening there.
So yeah.
So we're going to check it out.
Just keeping in with the mood of comments, we can say enemy... Right, no, my bad.
Check and set high score.
Yeah.
Check for and set high score.
Check for and set high score.
Cool. All right, let's try it out.
Really quickly.
Oh, we're dead. You got the high score because 104 is greater than the starting 0. All right, so now we start again. Notice high score did not reset. And all right, there's higher. You got the high score. All right, so now it's 232. We replaced 140. What if we die now? Oh, game over.
And no high score.
And no high score. All right. Logan, my good friend, guess what? We're done with our game, if you think about it. It's fully functional. We got levels that get higher and higher. We've got our score that gets higher and higher. We now check for and set our high score. So at this point, if any of you viewers out there have your head swimming like crazy, stop the video. You've got a game, build up to here, take a breather, come back, watch again. We've been going for almost 2 hours, unscripted, pure educational material. But if you're ready to take your game to the next level, we're going to look at some graphics. Let's make this thing look exciting. And we don't have to change our functionality. We just need to add some graphics, which is really easy. Now, what I want to do is first tell them that in regards to graphics, there's a couple of ways we can go about handling graphics. Now, when I say graphics, what I'm talking about is JPEGs and bitmaps that were created in Photoshop or Paint or some other graphics 2D type application. And now we can use these file textures, right? These graphics. Now, we can put them in the game 2 ways. We can, A, embed the graphic into the executable itself. And we're going to show you guys how to do that first. And we also have the ability, if need to, I should say and/or, load the files from the disk itself, the hard disk. So let's start out, Logan, by just putting a very simple player and enemy on the screen. Okay. So let's replace what we've got at the moment. So here we go, guys. Again, things are going to get a little bit more involved now.
So we need to start showing graphics. And a control that would let you show a graphic is an image.
A T image.
So we can set an image in, and we need to adjust its size because our player and enemy are set to width and height of 32.
So 32 by 32. Of course, if you guys go into Photoshop and make them a different size, you see how it works. Set your width and height differently. Now we need to load a graphic. Before you load the graphic, Logan, drag that folder over onto the screen on the right-hand side over there.
So we've got
What he's doing right now is he just opened up the project folder.
Yeah, this is our projects folder, this is the folder for Flea, and now what I want to do is we've got all of our graphics off screen here. I want to copy them all into our project folder so they're all available.
Okay, so you guys just didn't see the other folder, not a big deal. So there they are. We've got an enemy bitmap, a player bitmap, and then we got a background 1, 2, 3, game over high score, a HUD playing, a HUD standby, and a start splash screen. Now, notice how we have a couple of bitmaps and everything else is JPEGs. Any particular reason, Logan?
The reason for the enemy and player to be bitmaps is that we need to use transparency on those. We need, since the enemy and the player are no longer perfect squares, they have some edges that are rounded, and on those parts we want to see through the enemy or the player and see the background behind them. Okay, so very cool. Now let's go ahead and double click on player. All right, so that's our player. It's the Doom character that we borrowed from id Software's game Doom, and again for educational purposes. There is our little spider. Now you'll notice, like I said, look at the background colors. They're green. They're bright green. This is for what Logan said a second ago, transparency. We're going to mask that out so that we can see through it in just a minute. So let's walk through some of our other pictures. Ooh, a background for the game. Another background for the game. Another background for the game. A regular game over screen. Congratulations, you've got the new high score screen. A simple HUD, but in the playing mode. A simple HUD that is not in the playing mode. Now, I don't know if we're going to do this or not. Oh, yeah, and finally, a splash screen that tells the player to hit start to begin. I don't know if we're actually going to do this or not, but Zach has suggested that perhaps we create some free training videos showing you guys how he created each of these graphics in Photoshop. So that might be some supplemental videos that come out in the very near future. I'm not yet sure. You guys can let me know if you're interested or not. Now we know what our graphics are. Let's show them first how we can embed a graphic into the actual executable application. Okay, so here we've got the start of our new player. And if we look under localizable, one of the properties we have is picture. Okay. And that allows us to load a new dialog, which is the picture editor. Picture editor has a load button. Okay. This load button will take us to a dialog where we can pull images in. Okay. This is the player, so we want to grab the player graphic, the player bitmap, open that up, hit OK to it, and there we go. He's there, but the edges are still green. We wanted those to be transparent. So if we go down to miscellaneous, we can activate transparent. Now, transparency with an image by default is kind of an automatic thing. We painted it in green, it recognized the green, and set that to be the transparent color as soon as we set transparent to true. Okay, very cool. Now, at this point, what we need to do is we need to replace our white box with the player. And we can make this really simple so that we don't have to modify any code by first, let's select our white box, and change its name from player to anything else. As a matter of fact, I'm going to actually cut the text out and just name it to box. So we just did a Control-X, rename that, and now we're going to go to the player graphic, and instead of its name being image 1, he's going to paste player in. Now, when you hit play, go ahead and hit play. Watch what happens. And start. So he's moving, but look at that. We've got that blocky movement back. What's going on? Well, if you guys remember earlier, we disabled our shape so that the on-mouse move was not recognized by the shape itself. It was just always handled by the form. Well, we need to go in and disable the image so that, again, the mouse move is read by the form. Okay. So we'll grab our image, and yes, there we go. Enabled is true. If we set that to false, and we run again, there we go. We've got our smooth movement
Very
back.
smooth. Very nice. I love it. All right, with that out of the way, we can you can go ahead and kill that if you want to.
Let's go ahead and drop another T-image control down. And 32 by 32, setting it up for bringing our graphic. All right, let's go ahead and load in by coming up here to picture. Hit the little buttons, load, and bring our enemy in. All right, very nice. Now let's go ahead and transparent to true. Excellent. Now we can come up here to our red box. Let's cut the word enemy from name and name it something else. And let's go over here to the actual enemy and paste that enemy in as its name. We can go ahead and kill the red box. And hit play and see what happens. Dun 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 dun. We've got some graphics, yeah, and we die. So everything still works the same. All right. Let's go ahead and close that down. Now, that's bringing in and embedding graphics into our application. what happens when you end up in a scenario where you don't want your executable file to be really large. Instead, you want to load the graphics on the fly when the application is running from the hard disk. Well, it's simple. We first need to know where the graphics are stored. Think about it, guys. How often have you installed games like Doom 3 or Prey or whatever? And you don't find an executable that's, gigantous with millions of images inside. No, you find a very small, clean executable, and the images are stored in different locations or through different methods, but they're not stored in the executable. So in this case, we need to load these images, and the first thing we need to do in order to load the images is we need to know where the images are stored. And right now, we're keeping our images with our executable file, so we need to know where is the executable file running from. Logan?
Well, the executable is right now running from our projects folder. If we jump back over here, we see we have our Roland projects within Flea. There's the main executable.
Okay.
So we know where it's at. The problem is we can't just write this whole location, and otherwise the program will only work for us.
Okay.
And the only way anyone else could make the program work is to first sit down and make a folder structure that mimics yours before the program will work.
Right.
And that's just way too kludgy, way too much trouble.
Okay. So, again, this is something we would normally use a variable for, what we're about to show you. We're going to use a label.
So this means that we need to store this path, but we need to have it automatic within our app. Once we have it within our app, we have to remember it for future use in the app, so we'll need a place to put the data, which will be our label. And we can just go and call this label something simple like path.
Sounds good.
All right. Now, how do we get the location of this form into this path label?
Once again, this is a little bit on the complicated side because now we're going to start dealing with some fancy stuff. So if it confuses you, just type along and all is good. All right, let's go.
Well, now the first thing we need to think about before we even decide how to get the path information is we need to decide when this path gets populated with information. So far we've had a few different things cause something to happen. We've had timers, we've had buttons, but we don't want this to have any delay to it. We don't want to wait on a player. We just want to put the information into path as soon as possible.
Okay.
So for the as soon as possible element of this, I'm going to jump over to the Forms events and show under the miscellaneous category that we have on create. This is also the default event that would happen if you were to just double click on it.
Meaning that when you first launch the application, you're going to run the code from there.
Right. As soon as Delphi puts the form together for you, have some stuff of your own happen.
Okay.
And for us, that's going to be to store that path information. So we know we have path. We know path is a label, so it has a caption. Now, what do we want to set that caption to? Well, we have some information that's available to us in the application object. So we'll say application, and the piece of information I'm interested in is exe name. The program always remembers where it's at the current moment. And we can show this if we run the app now. We can see, and stretch this out a little bit, that the application is aware of the fact that it is within the C documents and settings, blah, 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 Flea folder.
Takes you all the way to the end of the Flea folder, and it even tells you, of course, the application name, because that's what we use, which is flea.exe. But that's a problem, because we want a path to where our graphics are. We don't want to know the name of our application. So we need to extract out that path.
And fortunately, there is an extract file path function.
So extract file path, and then inside of it, we feed it our file name, which includes the path and all. So now if we run it,
there
check
we go.
that out.
We have the path by itself.
Yeah, we no longer have the exe name in there. We just have the path to where the executable is, which is also where the graphics have to be. So now we can refer to this caption anytime we want to load from it. So Logan, let's go ahead and let's see, what do you want to do first?
We could almost just do the game background. Because
right.
we do the game background, leave that alone for a while.
Okay.
And then...
so we'll just do one background.
Yeah, just one background for the time being.
Sounds awesome. So when it loads, let's go ahead and jump back over to our designer, and let's put an image in that fills up our whole background.
So we'll put an image in. In order to easily fill the background, I can just jump over to its properties, go to Visual, and set its align to AL Client, and it will fill the area that it's placed in.
AL Client, boom, the whole thing. Excellent.
And
let's go ahead and give it a name.
Yeah, name this, and we get back to it easily. We'll call this Game Image.
All right.
Now back in code, we can load the image file.
And again, remember what procedure he's in. He's still inside the form create, which means the first time you run this application, this is the code that's going to happen. So before you even see your window pop up, we're going to populate the path.caption with the actual path, and then Logan's going to take that image and he's going to load a picture into it. And here's how you load the picture.
And there's the key. We're going to say the game image dot picture dot load from file, and then feed it a file name. Now we've figured out where we're at, so we can take the path.caption, place that in, so we've got our path to the image, and we can append to that by using plus, and then feed it a file name. And that file name is going to be, well, if we don't magically know, we can always go and look and see it, okay, background 1, that's what I want to use.
Okay.
So bg1.jpg.
Now, right now, we are indeed dealing with concatenation. If I can, real quick, Logan?
Yeah.
I'm going to grab this. I'm going to come over here to the whiteboard. And even though we're going to have a much bigger lesson on this later, when we deal with strings and we append, the result is the two things added together, meaning that if I was to say that the, what did you call it, path?
Yeah.
Path.caption equals, and then, or colon equals, colon equals, and then let's say I did quotes, Jason, in quotes, plus, and then let's say just two quotes with a space in it, and then plus, and then quotes, Busby, in quotes, terminate. If after this line ran, I check the inside of this, what I would actually see would be the following. Jason, space, Busby, all is one word. And that is why I promise. So this is what concatenation does. When you use the plus operator dealing with mathematics, you are truly adding the numbers when it is numbers you're dealing with. When it's text, or strings as they're called, these are strings, when you do that, it simply concatenates or appends this piece to this piece. And then it appends this piece to this piece. And you end up with this result. So you're just appending. That's all. So what Logan did is he took the long path and he appended to the end of that the name of the file, which was like bg1.jpg. And now what the computer saw was C:\\\, blah, 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 backslash, blah, blah, so on and so on, backslash bg1 dot, that's a dot, I promise, jpg. So that's what ends up getting stored because this plus made this get concatenated to the end. Okay? Let's go ahead and jump back over.
And now, because you've brought up concatenation, this brings up one other thing I was thinking about. If I was a really attentive student and I was watching the whole problem between caption and tag when we were storing and setting numbers, we used plus there, and we've just now said that you can, in fact, use plus along with a caption. So I might be thinking, well, wait, why can't I just take the caption and equal to the tag? Well, we had the type mismatch, so I already know, okay, we can't do caption to tag. Why couldn't we do caption plus caption?
Okay, because let's say that the levels caption currently contains
just one.
A 1, right? So remember, that's got to go in quotes because it's text. Now, if I say plus, well, we know we can't just do a 1 because that's
we have the type problem.
So instead, I'm going to do plus like that. Put my 1 in quotes.
So now they're both strings.
The result of this that you would see would be the following: 11. Not good.
And that's wrong. That's why we had to mess around with converting and storing things in tags, is when we put those numbers together, we had to have Delphi consider them as numbers so that it would mathematically add them.
Exactly.
When we're talking about captions, we're talking about strings, and if we do manage to add them, we are not adding, we are concatenating.
Precisely. So that is what you're seeing going on in that line of code that's highlighted yellow right now. The caption plus the file name.
So
let's run it.
Let's try it out.
And now we have, this is a really, really great example right here. By default, our image component has support for bitmaps. Okay?
Right.
If we try to, and it also has support for JPEGs, if you go in and hit the load button and load it actually from your hard drive so that the file is embedded in the executable. But now we're doing a load. So loading this picture, it doesn't know how to deal with a .jpg file. So we need to add a new uses up top. We're going to need to use a new library.
So completely stop this out. Go all the way up to the top. to our
Remember
uses.
uses. We've done this once before. We need to use the library JPEG.
And with that, now we understand what a JPEG is, and we've loaded our image.
Ooh, but now we've got an even cooler problem. Hit the start button.
You can't see our characters except for the occasional redraw flicker behind it.
All right, here's what I want you guys to think about for just a second if you're confused. Ooh, you got the high score. Not bad for not being able to see. Think about this, guys. What was the order of creation? Logan created the graphics for the player and enemy first, then he created the image that filled the whole area second. That means that image is over the other two. So Logan needs to send that image to the back, basically send it behind the player and the enemy. Watch how easy this is to do.
So the
image is selected. He right-clicks on it, Control, send to back. Hit play.
There we go.
There we go. Hit play. Now look at this. We got another interesting problem. All of a sudden we can't move our player no more, and we're dead. And we can see our caption, which I'm no longer interested in seeing because, well, we know that information's good. And we can just hide it. So let's go ahead and first grab our path.
Yeah, the path thing is easy. At the very bottom, under visual, we have a visible property.
So if we set it to false, it's now hidden at runtime.
So very good, all gone. But we still have the problem of no movement. We're not picking up control from the mouse anymore.
Uh-oh. So how about instead of using the forms mouse move, we start using the image mouse move? Because right now, the image is in the way of the form, so the mouse move is never hitting the form's mouse move. Instead, it's hitting the image's mouse move, which doesn't do anything. We don't have any code there.
We go to the image, we go to mouse move, there's nothing there. As a matter of fact, while I'm here, I'm going to go ahead and create that procedure.
Double-click it. All right.
So we've got our mouse move image. So mouse move for the game image. All we need to do is take our code from the mouse move of the form, which is the form's mouse move.
Good.
We can take all of this code, cut it,
Control X,
and paste it,
Control V,
within the mouse's image move.
Yep, and then when he runs it, it's going to clean up the function that's now empty, and look at that. How nice is that? Now, some of you might be wondering, why did we move that code to the image as opposed to just taking the image and disabling it? Well, we now can do something nice with the mouse. Notice how right now when you hit start, we got the mouse is a, regular mouse arrow. Now let's go ahead and go in to another property available, which is if we come down to the cursor, let's change the cursor now to like crosshairs. Now look at that. When the mouse is over that image, it's crosshairs, and when it's over everything below, the HUD and all, it's a regular arrow. Ah, that looks so much nicer.
So it centers up on the player much more nicely.
Absolutely. All right, very, very cool. Okay, we can worry about changing images shortly because that'll be the final, most advanced part. How about a HUD?
All right, time for a HUD. Since we saw the HUD graphics we had that completely replaced this background, we're going to take the panel itself out of the mix.
So
we're
going
to take
cut
all
these
of these
guys out.
controls out, cut them, and then paste them right onto the form. That way we're free to delete this panel. And then we can grab an image and use that for our bottom instead.
Okay.
So we can take this image, let's see here, align it bottom.
Okay.
And set its height to 42, just like the panel was.
Okay, nice.
So we've got this in place. Now, let's see. Do you want to start loading the images into it or start working on placement?
How about we do this? Let's do placement first. So you need to go ahead and physically load let's say a running image in when the game is actually running. So let's load that HUD.
Okay. And just to stop for a second, we're right here by name. I'll take the opportunity and name this guy HUD.
Okay,
so we've got him
sense.
named.
Okay, so let's go ahead and come up the picture, open up the dialog, hit load, and let's do HUD playing.
Just so we have a better idea of where our score and our level goes.
We're actually going to load it at runtime, guys, but right now we're bringing it in so that we can easily align our components, the label for the score and the level and all that on it. So let's go ahead and put that stuff back on.
Here's all of our labels. We'll move them down. And
bring the front, or
yeah, there's a few problems. Or we can just take this guy and
send it back. There you go. And ooh, that's nasty with all the gray. We need some more transparency. So we'll select all three of these.
Go down to under label. Was it visual or was it miscellaneous?
Right there. Up under miscellaneous and true. Oh, so much
better.
Nicer. Let's give it a color. I know ours originally didn't have a color. Let's do something like a green or something.
So under the visual font and then the font color.
Font's color and some sort of light green.
There's a light green.
Money green, yeah. That way everybody can see it easily. All right, so now let's go ahead and see how well we can center all these up.
Okay. So I'm going to move them up. I'm going to nudge them up just a little bit so they're a little bit farther away from the text.
Okay.
And then we need to start centering these individually. Score looks pretty good, actually.
Score does look good.
So we can take this guy, nudge him left a few pixels.
Okay.
That looks good. High score needs to be moved over somewhat.
I would say high score and score both need to be stretched out just a little bit.
You're right, because we're going to get into numbers that are more than 3 digits, and it only looks like about 3 would fit there before they start clipping on the ends.
Right.
So, I mean, we've got these boxes, so we'll just move almost to the edges of these the visual boxes on the graphics.
Okay, cool.
And same for high score. Right about... It's being so picky.
That's good.
Yeah, I know. It's being too picky. All right, perfect.
All right, now that's in place. The next thing we need to worry about is our start button. But I don't want to drag our start button from up there down to there.
I don't know. That's just not doing
it for me. That just doesn't work. So what we need to do is somehow make it look like that button that's a graphic button is an actual button where a person can click on it and it works. But to do that, we need to have some sort of way to capture your mouse click event in that area. And the best or quick, cheesiest, and easiest way to go about doing it is we'll just simply create an image on top of the start button. We won't load it with anything, but we'll change its name to start, which means we might want to change our start button name
we'll
first.
Go and quite literally steal the name start, put anything to mark that we're going to delete it soon.
Okay.
Go to the image, and the image's name is now start.
Now, Delphi is smart enough to know that the code now belongs all up under that guy because its name starts. So all of its code is still there.
Right.
And we can kill that button now.
And we can verify that by going to his events. And he's still linked, but this new guy... the code is still there, and it knows what links to what. I do want to go and double-click this, just so that we have the... I shouldn't have named this yet. Check it out.
Oh, okay.
I renamed it. It copied that code over, so...
I gotcha. Since he renamed it, it copied it
It's all in the order of the way you do stuff. Just because I had named that first, the event itself got named to AA click.
So all he did was cut the code out of the AA button on the click event and paste it up in the new start click.
And with that, now we're ready to recompile, and we can see that it cleans up that AA click.
So let's go ahead and get the AA button out of there now.
So yeah, now we're completely done with the button.
So now if we hit play and run it, all right, we can actually hit the start button, but a couple of things. One, we didn't see anything happen in regards to the HUD. Number two, go ahead and stop it and start it again and watch this. You didn't see, when the mouse goes over it, the mouse was just a regular arrow. Let's make the mouse into something like that indicates you can press it.
We could do something like change it to a hand pointer to indicate that that's a hotspot.
So again, going back to the cursor up under the visual and hotspot. There we go. So if we run it now before you click it, look what happens to the mouse. Ah, so nice. Now when we click it, we need to have the graphics change. So at this point, we'll go ahead and close it out and come in here and let's unload our graphic.
To unload the graphic, we can just go to the picture property, load the image or the picture editor again, and tell it to clear.
Okay, so now it's completely gone. Now, when our program is first run, we need to make sure we load that graphic in. So we can come back over to code.
And up near the top, I'll scroll all the way up to, down a little bit, there's our form create.
Right.
The form create is where we loaded our background picture, so we could load our HUD picture. And since this is a lot of stuff in this line, I am going to get lazy, copy this, paste it, and just start changing names. So now we're referencing HUD instead of game image, and the picture we're interested in is one I can't remember the name to, so we have our ever handy folder sitting here.
HUD _standby, because by default the game is not playing.
So HUD standby, and we can paste that name in here.
Okay.
And I guess we're ready to run.
And
hey, there we go.
Look at that. We're in standby mode, and we're waiting to click on the start button. Now when the start button's hit, we need to simply load a different graphic in.
Okay. So grab this, copy this piece of code, take it with us, so that we can go to the point where we start, which is when the start button is pressed, or the start click procedure. So as soon as we start, we're resetting all the game elements, and I'll just do this really near the top. I'll say load the picture in, only this time we're not loading the standby anymore, we're loading the playing version, which if we look over here is HUD playing. We can paste that in, and we could even add in a comment saying something like, update the HUD graphic. Like so.
Okay.
So now, if we run the game, we've got our standby graphic, and you see level and score are grayed out. Start is highlighted. We can start the game. Start becomes unhighlighted, and level and score become active.
Okay.
So all is good right until we die, and this doesn't get reset. It still looks like we're playing right now. It hasn't reset back to standby, even though the game has ended.
Okay. So now we need to go ahead and correct that real quick.
So we can jump up to what happens when we get caught. So here's our when the enemy catches us code. And we can jump over to, I guess, anywhere in here, because the HUD just needs to go back to standby as soon as we get caught.
Okay.
I'm thinking for a second. Yeah, we'll do it immediately. I was looking at the fact that the message catches where we're at and hangs at the message until it goes by. In a minute, though, that's not even going to be a concern.
Gotcha.
So I should be able to just paste. I know, trying to cheat, can't cheat. But I do want to copy. I've got my heart set on copying that line. So scroll back down. We'll copy it. Now, once again, back up to enemy timer within the collision check. We can paste in the HUD picture, telling it to load, and we're going back to standby. So there is our caps locked standby. Standby JPEG. And there we go. And one more comment to say, update the HUD graphic. Like so. Now we can run, and we can see we have the standby graphic, we have the live playing graphic, and then we're back to standby as soon as we get caught and the game ends.
Very cool. Now, of course, we need to go ahead and change our final graphics out for the when the game ends. Instead of using these corny message boxes, let's go ahead and have that flip.
Okay, so no more message boxes. We can erase those out now and replace those with images. And let me just copy this. So we'll copy the load picture line again, and I'm going to paste it directly over show message. So now we're loading a picture instead. We're not talking to the HUD anymore. We're talking to the game image, because this is the full background image we're looking at. So game image, and we're loading whatever happens when the game ends and we get a high score. So let's look over in our folder. We've got a game over high score, which is precisely what we want. And select this, drop it in, and then same thing for the standard game over message. We want to have an image represent that, and I'm just going to take out the high score bit of that, so we have standard game over. So, I don't know, let's go and jump in and test it.
Okay.
So we're playing, and we got caught. Game over, we got a new high score.
Okay.
Now we're playing,
oh,
we
man,
haven't,
yeah.
So a few things we need to
always
reset.
have high score.
And if I die more quickly, standard game over screen. So those are good, but it's not resetting when the game starts. So remember, all of those elements we need to change and update. We need to keep this up to date as well. We are updating the HUD graphic. We can update the background graphic as well. So we can say update HUD and game graphics. So reloading the HUD picture, reloading the game image picture, and that needs to be set back to that BG1 JPEG.
Okay.
So, alright, good. Got our game background. We've got our high score background. We've got our normal game over background. And every time I'm restarting it, it immediately resets to the game image. So that game image is always shown when playing.
Awesome.
So one step closer, but you see, as soon as we run the game, we've got the game playing background already in place.
Mm-hmm.
And if you remember back when we were browsing through the images, we had a splash screen for the whole game.
Yeah.
So we want to show that instead as soon as the app loads. So we can say that this is game image. If we go back up to the form create, I'm going to set this and change it to our splash, which I can just look over here and find that it is called start. So back here, start can be pasted in instead of game background. We run, and now we have the flee splash screen as our default screen until we start playing. So we've got splash screen, gameplay screen, high score screen, and normal game over screen.
Excellent.
Now, looking at this, let me reload the game again. As soon as the game loads, we've got our characters already visible, and because we've been messing with stuff, they aren't even in the right positions. So, I mean, maybe we could clean this up a bit and have these characters hidden until the game starts.
Sounds good.
So, hiding them until it starts sounds easy enough. We can just select them. Under visual, we have their visible property, which can be set to false. So if we run now, that's good, but we can't see anything. We're never turning their visibility on, so everything is just invisible until we get caught. That means that along with all the things we set up when when we hit the start button, we now also need to set our characters to visible. So we've got our player top left, so we say enemy dot visible is equal to true, and player dot visible is equal to true as well. So now, characters not visible, we start the game. Now the characters are visible, and one last thing to clean it up would be to make the characters hide again after the game ends.
Okay.
So to finish this all off, we can go back up to where we're setting some graphics as soon as we get caught, and say enemy dot visible set to false, and player dot visible is also set to false. So hidden, visible, hidden again. So that keeps everything clean. We only see the game background and the game characters while the game is playing. In all other cases, those things are hidden and are replaced with things like start screens and game over screens.
Very, very nice. Okay, so
yeah.
Guess you're ready to do the complicated part?
Sure, let's get to it.
All right, so we need to go ahead and show them the modulus thing, huh?
Yes, I'm afraid so.
All right, so what we're going to do is we need to make our background change. To make our background change, what's going to happen is we want the image to change every so many levels, like every 3 levels. And we can do this easily by using another built-in function. It's called modulus. And modulus simply means take a number, divide it into another number, and what kind of remainder is there. And there's a very unique pattern that gets generated by a modulus of something. Let's go over here for just a second and come down to Photoshop, and we'll just kill all this stuff out real quick. Now, modulus. What we're going to do is some number, and I'm just going to say mod, and some other number. Actually, you know what, to make this even easier, instead of just saying some number, how about I just come right in here and say level?
Okay, because that's what we're going to base this on. Just to reiterate, the whole goal we've got going on here is we want the backgrounds to change after so many levels change. So we have a few levels change, and then it flips in a new background image.
Yeah, because I don't want the level to change. It's every 3 seconds. I don't want the background graphic to change every...
Yeah, that's such a short amount of time. It's going to be distracting with how often the background would change.
So this right here will actually give us a number. And it's a unique number. It's a pattern that's, well, actually, let's just see how the pattern gets formulated. So basically, what's the very first level? 1, right? And what's our mod number? 3. Now, let's take this and take a look at what this looks like. This means 3 will go into 1 how many times? Well, it won't. 0. So we do a 0.0 like such. Now, 3 will go into 10 how many times? 3. 3 times 3 is what? 9. So what's my remainder? 1, right?
Right.
So our first would be a 1. Now let's take a look, because now we go to the next level. We just upped a level, right? So we're at level 2, mod 3. So let's take a look at the math here. So this is 3 will go into 2 how many times? Oh, man, I need to come over here and do a 0.0 because it's 0. So, and of course, there's decimals here. I'm doing like kindergarten-type math here. Well, not kindergarten, but you get the idea.
Wow, I don't know what kindergarten you went to.
So what times 3 is 20? Well, or closest to? 6. 6 times 3 is 18. What is our remainder? Remainder is 2. So now our second number is 2. All right, so again, we increment to the third level. So now we've got level 3 by 3. And what is this? 3 divided by 3. How many times will 3 go into 3? One time. What's our remainder? At this point, the remainder is 0.
Nothing.
Because 1 times 3 is 3. 3 from 3 is 0. So the next number is 0. Remember, these are the remainder numbers. That's what's important to get through your head. Let's do another one, because this is where you start to see the pattern. So now let's say 4 divided by 3, because now we're on level 4. Now what does this equate to? Well, 3 will go into 4 how many times? 1 time, right? 1 times 3 is what? 3. 3 from 4 is what?
1.
1. Uh-oh. We have a 1. Now, is there a pattern forming? Let's do this again. I'll move right over here. So let's say the next level is 5 divided by 3. And this is equal to 3 going into 5 how many times? Well, it'll go into 5 1 time, giving us a 3. 3 from 5 is 2. Up, we have a 2 here. Let's do it one final time. So now we're on level 6. Level 6 divided by 3 is, well, 3 goes into 6. How many times? It goes in 2. 2 times 3 is 6. Yep, I'm like, wait a minute. So 6 from 6 is what? 0. Look what's happening up here.
And the cycle has just completed itself again.
Using modulus allows us to generate a predictable number pattern. 1, 2, 0. 1, 2, 0. The pattern's going to always be up to the number right before what you modded it by. Meaning that if instead of 3 we would have modded by, let's say, 4, the number pattern that would have been generated would have been 1, 2, 3, 0. 1, 2, 3, 0. If we had modded by 2, it would have been 1, 0, 1, 0. If we had modded by 8, it would have been 1, 2, 3, 4, 5, 6, 7, 0. 1, 2. So it's always counting up to the number right before what it's modded by and then flipping to 0. Make sense?
Oh, yeah.
Now, how can we use this to flip between 3 images? Logan?
All right, well, back into the world of Delphi. Now, we need to decide where this flipping takes place, what causes it.
Okay.
And it is the level change. Whenever we advance to a new level, so that would be the level timer.
So the level timer is a fantastic place to put it.
So right now, all the level timer is updating the level display. Now, we need to make this a bit more advanced and use the level timer to trigger the background change. Now, like we were talking about, we don't want it to change every time the timer hits. We want a condition. We want to break into a decision and decide if we're at a good place in the cycle to change the image.
Right.
So we can start the whole thing off with an if. So we can say if our level.tag mod some number. So you said you wanted to have this run by 3?
Yeah, we can do 3.
So if level.tags, so our current level, mod 3.
I think what you did, though, was mod it 2, didn't you?
Yeah, in our example game that we had before, that was 2.
Okay. So you want to do it 2?
Yeah, that's fine. The reason I did 2 is that's just easier to see because it happens faster.
Yeah, let's do that.
So if our mod 2 is equal to 1, then we'll change the background image. And I'm going to do this as a begin, just because we have more lines of code. So we have our end thrown in place for us, and now we can do whatever we need to do.
Okay.
And that is increment the background image.
Right.
Now this is where this gets just as complicated as the mod thing, just in the way you have to think. Because we're thinking, all right, great, change the image. That's easy. We can use the same image loading that we've been using so far.
Right.
The problem is we want this to be changed to a number-based image. We don't really have anything that's number-based in this entire thing. All of it's strings. Caption is a string. The number itself is a string. Even this BG1, it's got the number 1 in it, but it's still a string.
Right.
We need some way of having a number influence which image we load.
Meaning we need to store what image number we're currently using.
Right.
Meaning we can probably get away with using the game images tag.
Yeah, that would be a good place to store it because that's what's actually getting changed. So we're trying to keep the information as close to home as possible. So we could say that every time this hits, every time we decide to change the image, what that means behind the scenes is that the game images tag, or we could almost call that the image index, will be incremented. So game.tag, or gameimage.tag is equal to gameimage.tag plus 1. Move up to the next image.
Okay.
So move from image 1, 2 to 3, and so on.
But since we only have 3 images,
we'll run out of images really quickly, and we need it to reset.
Meaning we need another if now. Meaning that if we happen to get greater than the number 3, we need to kind of reset the tag back to 1.
So if we have gone over 2, so if we're on 3, or no, my bad. 1, 2, 3. So if we're greater
than 3, then what we need to do is take game image tag and set it back to 1.
So that we have a kind of looping thing going on where as we exceed our last image, we just go on to the first one.
Right. All right, so now all we need to do is just load the corresponding picture. And that's actually pretty easy. We'll use the same code we've done with gameimage.picture.load from file. And then we need to tell it what's the path. So path.caption. Plus, now we need to give it the file name. And we know that our backgrounds are BG1, BG2, and BG3. So we're just going to say BG in quotes. Now watch this. Now we're going to say plus. Now we're going to do an int to string. We're going to convert the number that is currently inside the image, the game image tag. We're going to convert that over into a string. So go ahead and put gameimage.tag in there. Meaning as game image is first a 1, then it's a 2, then it's a 3. That gets appended to the end of the BG. Now we need to append one final thing. So we'll do plus again.
Just for those trying to follow character by character, I have just closed off the parenthesis to opening the into string.
Okay.
So I've closed off the parenthesis for that. Now we can go and append the last part of the string, which, like you said, is .jpg.
.jpg. All right. Fantastic. What do we have? What do we have? What do we have? Compile and run, ready to begin, flee, and here we go.
Level 1. Level 2, no change. Level 3, and so on, not changing ever.
Something's wrong. What is going on? We must die and find out.
Alright. So we're saying if the levels tag mod 2, so if there was a remainder, the reason I did the remainder thing is because once we get to 2, we start at 1, we increment to 2. So if I did 2 mod 2, then it would change immediately when we got to 2. That's why I set it to 1.
Okay.
And our game image tag.
Oh, what do you know? We got to do some of our own troubleshooting on the fly here. Fantastic stuff. So instead of...
I see what's going on. We just didn't let it run for long enough. Here's what's going on. What is the game image tag when the entire program starts?
Oh,
If we look at our game image and we look at its tag, because, I mean, we're not affecting game image's tag until right now.
We're telling it to add 1 to it, and it's currently at nothing, or 0, isn't it?
And under, here we go.
Yep, so we had to let it run a little bit longer.
So what happened is, as soon as we hit this for the first time, we were at 0, so we got set to 1, and loaded the screen for image 1, so we saw nothing. If we go ahead and bump this up to what it's supposed to be to start with, 1.
Again, that's select the game image and set the tag to 1.
Then we should be set.
And here we go again with some more of my annoying music. Dun 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 dun. Okay, I'm kidding. All right, so we're running.
And 3 brings in a new image.
And
4 doesn't change. 5 gives us our third background. 6 should again do nothing.
And then here comes another one.
7 resets us all the way back around.
Very nice, very nice.
There's just one thing I want to check and see if this is being caught yet. When we're somewhere else, so we were on the blue screen when we died, and now we start, and it starts back over.
Okay.
So, that's all good. That's good, I think. Yeah, unless there's...
And it starts all over. It starts all... Did we reset the game image tag?
That's why I did that check, and it reset then. We're not explicitly resetting the game image's tag, so...
Let's just do it.
Yeah, just to be sure. So as we're resetting elements, one of the things we can do is say the game image's tag is set to... I think this was probably a bug that existed in our other version. We just never came across it.
Probably so.
But while we're loading the picture for the first background, let's again set the tag back to 1. And with that in mind, it wouldn't even matter what we had set in the designer. We could have set something completely arbitrary.
Because as soon as you hit that start button, put that in. Yeah, exactly. Now go ahead and run it. As soon as you hit start, it initializes it to 1 for us. So we'll verify real quick. Dun, 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 dun. And there we go. Beautiful. All right. That's it.
So a big save to the project.
Okay. And go ahead and just run it.
And there we go.
Go ahead and let it run around real quick and kill you.
Click.
Ladies and gentlemen, you have just created a game over the last 2 and some odd hours. 2 hours and some odd minutes. We thank you very much for joining us with this video training episode from the Delphi Training Series. Again, we are developing this for you guys over at 3dbuzz.com. We're wanting to see lots of excitement both on 3dbuzz and YouTube about these videos. You guys keep the excitement up, and in return, you think this was cool? Oh, this is nothing compared to where we're going. We've got some crazy stuff that we're planning on doing. We're going to take the game development side into a much more interesting world. And we are also going to take just application development in general into a much more interesting and dark world. All right, not dark, but interesting world, I promise. So some really cool things coming up. Also, I would like to take just a second and thank all of the member sponsors of 3dbuzz.com, because it's you guys that make all of this possible. Thank you very much. And with that, thank you to all of the members of 3D Buzz for supporting what we do, and we look forward to seeing you again with the next episode of the Delphi Training Series. We're out of here. See you guys.